Good morning. Can you hear me? Okay, thank you. Yesterday we have done with the 5A till 5A programs. Today we are going to start with 5B from the 5th B program. Okay, so 5th B program is nothing but it is related to a problem like Tower of Hanai. Here the problem, whatever the Tower of Hanai is there, that is related to, it is one of the applications of stack. And here we are going to use a method called recursion. So we will see what is recursion first. Recursion is a method of solving the problem where the solution to the problem depends on the solution of the smaller instances. So whatever the small instance solutions we are going to get, that is going to be affected for the final uh, solution. So solution is depends on a small instances. So what is this problem? First we will understand. In this problem there are, you can see in this we will be having three poles, pole 1, pole 2, pole 3. That we can take it as A, B, C, where A is a source and C is a destination. If you take A first, pole 1 is a source, pole C is a destination, and we are using a temporary pole, or you can tell it as a auxiliary pole as 2, which is going to act as an intermediate between these two. And this here, the discs are placed in such a way that the smaller disc will be at the top and the bigger disc will be at the end. So in the same fashion, we have to arrange the disk. We can't arrange in a random way, or the small disk has to be in the down, all those things, because the bigger disk has to be in the down. And initially the pole 2 and pole 3 will be empty. Then all the disk from the A has to be transferred. That is from pole A, pole 1 to pole 3. A, B, C. Why I'm using is we are going to use the same thing like in our program. We are going to use A, B, C pole. So I'm using A, B, C. A is nothing but first one, that is a source. Second one is B, that is intermediate. Like we can use it as a temporary or auxiliary pole, and the last one is a destination. So all the disk from the first pole has to be transferred to a that is pole C, that is the last one, and using the rules we have to follow while doing this problem is, first one, only one disk can be moved at a time from one peg to other peg, and these are all called as a pegs. Okay, so each only one disk can be moved at a time. We can't move more than one disk. And second one is smaller. As I have already mentioned, the smaller disk is on the top of the larger disk at any time. Only one disk can be used for storing the intermediate disks. Only one peg we can use for the, we can't use two poles at a time. We can use only one pole to as a intermediate. Okay, so this is the rules we have to follow while doing this problem. You can see here, like manually I'm showing you. First we will be having a pole A, pole 1, pole 2, pole 3. First from the pole 1 we are going to transfer one disk to a pole 3. So here you can see one disk we have transferred to a pole 3. Next, after that we are doing, we are going for the next one, that is we will be having this two disk, and one more disk we are using, like we are transferring the disk, second disk. I'll take this as a first disk, second disk, and third disk. So second disk we are going to transfer from the source, that is pole 1 to pole 2. So only one disk at a time we are transferring, and we are using only one pole, only one, on the one pole we are going to transfer the data. So next, in the next step, what we are doing is, here you can see all the three poles are having three disks. So I can shift the disk 1 from the pole 3 to pole 2. So that we have done in this step. That is, we have transferred the pole from the pole 3 to a pole 2, the disk 1. So this is in the fashion, that is that a larger disk is at the end and smaller disk is at the top. Then we will be having a bigger disk, that is a disk 3. So disk 3 I'm using as an intermediate here, the pole 2, and I'm transferring this bigger disk, that is the disk 3, from pole 1 to pole 3. Once I have transferred that, I can once I have transferred this, so in the pole 3, we have the larger disk. Now we have to transfer the second and the first disk. So what we can do is, we will use the source as an intermediate, and I'll shift this first disk to this pole 1, and the second disk, I'm going to shift to the third one. After this, from the pole 1, we are shifting the small disk 1 to pole 3. So this is the fashion how the program, like how this problem we are going to solve by uh, following the rules that we have to do in this. So recursion is, we are calling each and every time the same function itself, and so it is going to follow the method. Okay, this is a program where we are going to run we are going to solve this tower of Ni with n disk. So here the program, first we are going to include the stdio.h header file, mat.h, as we are using the mathematical thing. So lib.h and limits we are using here. Only the thing is, why we are using limits. Uh, Okay, so then it is like a void main. Here we are entering the number of disk, how many disk are there, scanf, percentage D and N, the number of disk. Then the tower of, here we are calling a function which is recursive. That is towers N comma A is a source, B is a temporary, like you can take auxiliary peg, and C is a destination peg. Now we will go for the function, that is, once it is calling, we will go here and that is the function name is, it is not going to, so we are giving a return type as void. Towers is the name of the function. Here int n is the number of disk. Char for source, temporary and destination. First we are checking whether the peg is having only one disk. If n is equal to 1, directly I can shift that one disk from A to C. Okay, so directly we are going to shift that. So printf, move the disk 1 from peg, that is A, to peg C, peg C, that is source and destination. Directly from source to destination, we are transferring if only one disk is there and equal to 1. Next, if it is not equal to 1, it will be more than one disk. So what I have to do is, take n minus 1 disk, then source, that is a, we are going to take for like source where from A we have taken the pole, then destination, that is C, the pole C, and temporary, that is all the disk using n minus 1 disk using a I'll show you. So we will be having 3 disks. What we have done is we have used so this is A, this is B, and this is C. We have used 3, and this is a source, this is destination, and here it is temporary. So what we are doing is n minus 1. So first step, we are moving the first disk to C. So once I have shifted here, this first disk will go to C. After that, we have to send the second disk. Can I keep that second disk on the peg 3? No, because smaller disk is there in the C. Oh, I can shift only the second disk to a second like peg A, peg B. So I'm shifting this disk to here. Then after that, what we have to do, we have C. We have used this C as a temporary variable, so like temporary peg. Why is 3? So the disk 1 is in peg C, will be transferred to a peg B. So what happens? N minus 1. I had three disks. N minus 1 disk will be transferred to a B using C as temporary. Same thing we have done in that. So what I'm doing, I'm shifting this. I'm shifting this one disk 1 to a peg B. So it will come here and it is 1. What I have done, we have used this peg C as a temporary variable, and sorry, as a temporary peg, and we have used B as a destination peg. N minus 1 peg you have transferred here. So the same thing we have written here in the system. In the program. So what we have done, if it is not equal to 1, if it is equal to 1, we are shifting from source to destination directly. If it is like if n is not equal to 1, if it is greater than 1, n minus 1 disk will be sent from source to temporary, that is in the temporary peg, using destination peg as a temporary, that is it is destination will act as intermediate and temporary will act as a destination peg. So after that, what movements that we are going to do, that you have to write till where you have to repeat this we have done. Then temporary will act as a n minus 1 pegs will be there. So if it is n minus 1 peg, temporary in the next, this one I'm telling here in this line, temporary will be having n minus 1 disk. You can see here n minus 1 disk. This n minus 1 disk has to be transferred to a destination using source as a intermediate. So same thing we are doing here. We are shifting the using source, because this is directly here one we have. So directly I can shift this one disk to here. Then I can't shift directly one to this. So what I'm doing, one I'm shifting to A, then two I'm shifting from B to C, then A, sorry, from A, first disk will be transferred. So if I'll show you once. So this is how, so here in this diagram, n minus 1, if I take, now I have to use A as a temporary, because I have one disk that already I am going to shift to B. And directly what I'm doing, whatever is there in B, whatever is there in A, that is a one disk. So directly from source to destination, I can shift. Okay, so now from B to C, I have to shift the disk 1 and 2, but we can't do, because 1 is lesser than 2. So in the middle, like this is third disk, and I have to put after third disk, second disk. I can't put 1. So what I'm doing is I'm using this A as an intermediate. So what we can do, first disk 1 can be shifted to A. So I'm shifting 1 here, and here we will be having only 2. So only one disk I can shift from this to this. Here the second disk will come. Then this first disk will be transferred from A to C. So second disk I'm going to transfer here, and then first disk, whatever is there, that directly are going to shift from A to C. So this is how we are going to do, and this is the way how we are using a intermediate peg to transfer the disk from source peg to a destination peg. So if you have any doubts, you can ask me in this program. The ma'am note doesn't. Can you hear me? Okay. Okay, directly if I have only one disk, directly I can shift from first, like A to C directly. A to C, that is from source to destination. If I'm having more than one disk, then I'm calling the same function, that is recursively I'm calling the same function to execute by itself. So here n minus 1 peg we are going to take. I'll use the names, that is A. Destination, here it is nothing but I'm using here it as a C, and temporary as B. So sorry, here I'm going to use temporary, that is B, as a destination using C. So if you want, I'll show you once again. So I will be having three disks. One, two, three. This is A. This is B. And this is C. So if n minus 1 disk, that is other than 3, 1 and 2 has to be transferred to B. B will act as a destination peg using temporary peg as C. C, I'm using it as a temporary, like intermediate peg to transfer the n minus 1 disk from A to B. So what we are doing here, we are shifting the first peg to the peg 1, sorry, the disk 1 to peg C. So here disk 1 will come, it will be B, this is C, this is A. Then I have the next peg, that is next in the peg A, I have one more disk, that is 2. I can't shift that disk from A to C, so I am shifting that to B, the next step. So here I am shifting. So second will be transferred to B. After that, I can't shift the 3 or 2 directly to C. So what I'm doing, I'm shifting n minus 1 has to be there in the intermediate, which is going to act as a destination here. So first peg from here, from C, I am shifting to a B. So now we can see from A, n minus 1 peg has n minus 1 disk has been transferred to a B, which acts as a destination. 1 and 2 will be there in B, and only one disk is there. So if n is equal to 1, directly from A to C, it is going to transfer. So we are calling the function. The function is going to shift the disk from that we are mentioning how many disks are there. One second. Oh, so that shifting, the moving of the, I'm calling the function. Here using this function, we are going to shift the data and it is going to print from where, which disk has been transferred from which peg to which peg. Okay, so I hope you have understood this program. I'll go for the execution part. So here we are giving the number of disk that is equal to 3. Then okay, you people can see the output screen, right? So here I'm giving the number of disk. People can see the output screen. So now I'm giving the number of disk as 3. Okay, so number of disk is equal to 3 and you can see the moves how it is. Okay, so we will be having the sequence of moves involved in the tower of Hanoi is move the disk 1 from peg A to C. Directly I am moving the, if I'm having only one disk, directly from A to C we are moving. And next one is disk 2. If we are having two disks, then the second disk will be transferred from A to B. Okay, because B will act as a destination peg, and then A has been transferred to the disk. One has been transferred from A to C. So what we are doing again, it is shifting to B. So B acts as a destination. Here we are using C as an intermediate. 1 and 2 disk we have transferred. Next we want to transfer the disk C. So uh, disk 3 from directly from A to C we are transferring without using any intermediate, because only one disk was there. So we are transferring that from peg A to peg C. Next, we will be having the two disk A and 1 and 2 in peg B. So what we have to do, we have to transfer the disk 1 from peg B to peg A. So that only first disk will be transferred to A, second disk will be transferred from B to C. Again, first disk will be transferred from A to C. So this is how we are going to get the output for this program. Next, we'll go for the next program. If you have any doubts, you can ask me in this. Power of an eye. We are not having, we'll move for the next program, that is Q. So we are going to see, you can see the screen, right? PPT. Okay. So here we are having a next concept, that is next type of data structure, that is nothing but queue. So queue, and the difference between queue and stack is, even queue is also a linear type of data structure. Here we are going to store the data in a linear way sequentially, and here the implementation, we can do the implementation using array and even using linked list, but linked list concept has been not started, so I'll explain you what is an using array implementation. You can see here the same array we have used, that is 2 is stored in the first 2, 8, 6, 4, 20, 24. You can see here, these are the array elements which has been stored, and we are going to have here that this will work in a FIFO manner, that is first in, first out a manner. So the element which has been stored first, that element will be deleted first. But if you go for a stack, their last in first out, the last element which has been inserted, that element will be a first element to go out. So this is how we are going to, and we will be having here two ends. One is the rear end and one more is front end. So here, there we are using only one end, that is called as a top. But here we are using the two ends. One is rear end and one more is front end. So what is rear end is the end at which the new elements are added. We are going to add a new elements from the rear end, and we are going to delete the elements from the front end. So the end from in which the new elements are added, that is called as a rear end, and the end from which we are going to delete the elements, that is called as a front end. So here also we'll go through our two conditions. One is overflow condition, one more is underflow condition. So if queue is full, where we can't put more elements, that is called as a overflow condition. If the queue is empty, like if it is empty and if we want to uh, display those elements, or if you want to do any operations on that queue, then it leads to a underflow condition. So the main major difference between queue and stack is, it is one ended and one index we are using, that is called as a top, and both insertion and deletion will be done using a top in the stack. If you go for queue is a data structure where we will be having a two ends. One is rear end and one more is front end. From the rear end, we are going to insert the data. From the front end, we are going to delete the data. So this is working in the fashion of first in, first out. So you can see here example, like being in a queue for the ticket counters. You can see first it is a front end from where they are going, but they are inserting to a queue. They are coming to a queue using a rear end, and they are going out from the front end. And here I can do the different operations on the queue. One is insertion, deletion, and display. So you can see anywhere I can insert the data element, and we can delete the element from any of the ends. Now, this is a basic concept of queue. Now, we will go for a one type of queue, that is called as a circular queue. So what is circular queue? Why we came to circular queue? What is the disadvantages of queue? That is queue. The disadvantages of queue here is, it is, if the, you can see here, it is a circular queue. The front end has been uh, wrapped with the rear end. So it is like, it is looking, it is a circular queue. So front and rear has been attached. So it is wrapped inside that. And why, what is the disadvantage? Is the situation, even though the space is present at the front end, we are not able to insert the data. If it is not wrapped, if, for example, if you take, if it is not wrapped, if it is a linear queue, if I delete from the front end, I'm going to delete the data. So if I'm deleting 24, uh, sorry, first in, first out. So first element we will take, that is 2. Element 2 I have inserted, and if I have deleted this element, I have deleted this two. Then 24 I have inserted. I have one more element to insert. In the linear queue, even though this zeroth position, if it is empty, it will show that the condition like overflow, because even though it is there, there is no access to go and fill this place, so there will be a wastage of memory. Example, I have deleted 2 and 8, and it is the curve, that is the front end is here. Can I insert the element again here? No, because there is no wrapping, like that is we are not having a wrapping between the rear end and the front end. To utilize that memory locations, we are using a concept called circular queue. So first we will see what is circular queue, how it will work, then we'll go for the program. So here circular queue, what from the, that is we are going to insert the data from the rear end, and we are deleting this from the, okay, where we are going to add the data, that is rear, and the end from where we are going to delete, that is front end, and I have inserted, and the elements will be there. If it is wrapped, then it is called as a circular queue. In the circular queue, we are using a rear end and front end to insert and delete your element. So how I can go for the empty space to fill? If I want to fill the empty space, if I want to delete, see, I have I have inserted the data in the zeroth position. Again, if it is from the front end, if I want to delete some of the element, what concept I can use to use that wrapping technique? So that is rear equal to rear plus 1, that modulus size. So this I'll explain you in the program how it is going to work, all those things. So it is these two things we are using to wrap the front end with the rear end. We'll go for the program. Okay, so here you can see rear is equal, initially the rear is also equal to 0, front is equal to 0. Then both will be incremented, that is rear equal to 1, front equal to 1. Then we are putting the data next. In this next step, we are inserting one more element, that is called as rear equal to. So front will be here only. If I want to start delete the data, it has to be started from the front. So front will be pointing to 1 only, but rear will point to the next location where we are inserting one more element, that is 50. After inserting 50, I have one next element, that is 20 to insert. 20 I'm inserting at the rear end. I have incremented, first increment the rear, then we are going to insert, that is 20. After inserting that, I have 70. So 70 I have inserted. If I want to delete from the, if I want to delete the data, then I have to delete the data from the front end. So the data which is present in the first location, that is 1, 10 has been deleted, and the front has been updated or incremented to a location 2. So now rear is at the location 4 and front is at the 2. So this is, it will work in this fashion. Program. Can you see the program? Program 6. Is this visible? Okay. So first we will start with this here. What is a program? Design, develop and implement a menu driven program in C for the following operations. What operations we are going to do? We are going to do the operations on circular queue. Okay. So what we are doing in the circular queue using a array implementation. I'm using array implementation using with a max like max size is equal to using some max size we want to implement an array. So first one is insert an element, say operations on circular queue we are doing. So we are making that hash sorry insert an element into the circular queue, delete an element, demonstrate the overflow and underflow situations, then display the data. So these are the four operations, and if I want to exit from that, I'm exiting from the program using exit function. So these are the uh, five functions we have to implement. Next here hash define, here you have to use even stdio.h to use the input output functions. Then hash define size 4, as I told you, for 4 value, the value for the four value we are using a variable name called size. Then we are globally we are going to declare char, that is a character. Okay, so here we are making it as a, this is not, this is a int. Okay, we are using a integer here. The q, that is a array, then front equal to -1, rear equal to -1. F and R is a front and rear, so both are initialized to -1. Now we are going for a main program. Okay, so main program, as I have a choice, insert, delete operations has to be done. I'm using a switch in my in the program. So first the execution will start from the main, void main int choice, that is a variable which we are going to use as an expression uh, for choosing the cases. Then we are using an element, that is ele, then for loop. Inside that we are writing that printf the circular queue operations. Then we are using a printf, that is one is insert, two what is two, what is three, what is four you are telling. And we are printf enter your choice, scanf what is your choice that you are mentioning. Once it has been mentioned, the choice, once you have read the choice, if it is equal to 1, it will go to the case 1. If it is equal to 2, it will go to case 2 or case 3 or default thing. So once it is the choice is equal to 1, it will come here and read the element to be inserted, which element we want to insert, that we have to give. Then we have to specify that, then we have to read the data. So the data, whatever we are going to read, the element which you are going to insert, that you are going to read. Then we are calling a function called CQ insert. That is for inserting an element, we are using a function called CQ insert. So directly the control of a program will go to a CQ insert. So void CQ insert element we are using. Then we are checking for a condition, that is whether the queue is full or not. Okay, if the, so what is that condition? Sorry, the function we are calling here, again that function name is CQ full, to check whether it is overflow or not. So for checking that, we are going for the condition called function called CQ full. So here it has to return either 1 or 0. So we are giving a return type as int. If front equal to rear plus 1, if it is equal to rear plus 1, or if it is front is equal to 0 and rear is equal to -1. If this is a condition, front is equal to r plus 1, that it has been exceeded the loop, or it front is at the 0 and rear has been filled with all the things. So here, if that is a condition, then it will return 1, otherwise it is going to return 0. Like it is in the front is equal to rear plus 1. Okay, so rare plus 1 is nothing but it is in the first position. Same, both are pointing to a 0 only. Okay, so that is R is equal to minus 1 and F is equal to 0. If that is a condition, then it is a full. Otherwise, one more condition, F is equal to 0 and rare is equal to, that is, no element has been deleted. So friend is pointing to a first location and rare is pointing to the last location. Then that time also we can tell that the Q is full. So then written 1, otherwise written 0. So if it written 1, here it will come to a else part. If it is returning 0, it will tell that the Q is overflowed. Then if it is not filled, if friend is equal to minus 1, that is, we have not inserted any element to a, as we have, as you can see, F has been initialized to minus 1. If it is minus 1 means we have not inserted any element. So F is equal to 0, then our value we are going to find out. That I will. So we have a queue here. First, it will check for which location it has to go. So R equal to, and we have initial, and we got R equal to minus 1. First, it is initialized to minus 1. So minus 1 plus 1, then modulus of size. So size is nothing but it is 5. Right? So it is equal to 5. If I do anything with this, then the remainder will be 0. So where R is pointing to the 0th location, and I'm inserting the data called element. So I'm inserting like here 1. Next, if I want to insert the next element, we have to go for the next value. Again, we are checking if it is equal to minus 1. If it is not equal to minus 1, then F will be at the 0 only. Then R equal to, it has been pointed, so we have to go for the next one. Like we are incrementing the R using that. So it will be pointing to a next, that is called as 1, and it is going to insert the data in that way. Once it reaches the last position, 5, example 4. Okay, once it reaches a, from 0 it will start 0, 1, 2, 3, and 4. Okay, once it reaches 4, 4 modulus of 5 is also equal to 4, and it will go for the next value, that is 5. 5 modulus 5 it is going to do, and what is the remainder? Remainder is equal to 0. So again it will go to the first step, that is first thing, and it is going to check whether it is filled or not. The two condition, that F and R value will be checked, and it is going to print the data. Next comes a deletion. So insertion is working in this fashion, and the next one is deletion. So if I want to delete the data, we are using a function called CQ_delete, and we are checking for the empty function, that is CQ_empty. So what is CQ_empty? Here it is a function where it is telling that whether the circular queue is empty or not. If F is pointing to minus 1 means it is a empty queue. So we have to return 1 or return 0. Return 0 if it is not empty. Return 1 is for if it is empty. Then I'll go for this deletion code, and if it is empty, we are going to print the underflow and return 0. If it is not empty, then queue of whatever the element is there at the front, that updated, that you are going to update for the element. Then if F is equal to R. If both are pointing to the same location after deleting the element means it is equal to, like, all the elements has been deleted. So you have to initialize F equal to -1. And if that is a condition, if it is not equal, then you go for the else part, update the F, that is front end, then you return the element. Okay, so F equal to, this is a deletion part, and we'll go for the next one for displaying the data. Void display int I, that is I is for the for loop for displaying the data. For displaying also, once again, we have to check whether the queue is empty or not. If it is empty, printf enter like empty queue. Or next in the else part, if it is not empty, first I is equal to front, I is equal to friend, I is not equal to rare, and you have to use a increment statement like this, I equal to I plus 1 modulus size. Only the thing is, while incrementing, we are doing the modulus with size. Rare also, front also, you are doing the same thing. So we are using a modulus of size to check even for the wrapping for from the last location to a zeroth location. We are using this modulus. Then printf, there you are printing the data. Then we are telling that where the rare is pointing, where the q is pointing. Okay, so first we will see now. I'll take f is equal to, what is the first? F will be at the position like R, 5. Okay, F, that is I. Then R is not equal, I is not equal to R means that is it will be equal to 0 or it will be 1, 2, 3, because from that end only you are going to put the data. So here first we will take F is equal to 0. 0. So I'll show you in the, so in the program how it will work. Okay, can you see the output screen? So here we have a different operation, insert, delete, display. First we will go for the insertion one choice, read the element to be inserted. I'll put as 4. Okay, 4 element, the element has been displayed. Then I'm inserting, we have taken a size as 5. So we will check. I'm going to insert one more element, that is 5. After inserting 4, 5 I have inserted, I can insert a 5 numbers. So 4, 5 I have inserted. Then we will go for the next element as 6. Again insert. See, it is showing as overflow because I have inserted already the 4 numbers. After inserting this 9, it is showing it's already overflow. Now I'm deleting one more element. The element number, the deleted number is 4 because initially first element, display better. So display, you can see here where it is pointing. That is at the rear equal to 3 pointing at 8 and front equal to 1 pointing at 5. So you can see where it is pointing. where the elements we are going to store here. If you have any doubts, you can ask me. Okay, I'll repeat once again. It is also working in the same way. The thing is, if you see here, how we used to increment the insertion. If I take the insertion part, the function, here first we are going to check whether it is equal to -1. If f is equal to -1 means it is empty. The Q is empty. So first I'll initialize f equal to 0. Then for incrementing, we used to do in other programs, IE++ or R plus. Here also R equal to R plus 1, but modulus size we are doing. Okay, I'll show once. I have taken, we have taken R. So initially size is equal to 5. Okay, so first, and we have taken here R equal to R plus 1, then modulus of size, right? So we have taken here R equal to R plus 1 modulus of size. Why we are using this is to use the wrap, wrapping of Q. So first I have taken R equal to 0. Let us consider R equal to 0. Once we have taken R is equal to 0, then I have to go for this. That is R equal to 0. R plus 1. So what I am doing is, here we have taken R equal to, first initially, what is initial value? Initial value is R equal to -1. So here we have to take -1 plus 1. So what is this? Modulus size is nothing but modulus of 5. Okay, so -1 plus 1 is equal to 0. 0 modulus of 5. That is nothing but 0. So we have get the location as 0, and I'm putting here 0. First initially R is pointing here. So over. Then so the next step, for the next time, what I have to do, we have to add for 0 R equal to R equal to 0 plus 1 modulus 5. So that is nothing but 1 modulus 5. If I'm doing 1 modulus 5, then obviously it will be 1. So again, the element here, whatever I'm going to insert, it will be here, it is 1. I have inserted the next element. I have incremented R and I have inserted one more element called, now R is pointing here. R equal to, again 1 we have, so it will be 1 plus 1 then it is modulus of 5. So again the 2 will be the remainder. Then again, so same thing, we are going to insert the data we have incremented and we are comparing that with whether it is equal to size. So what we are doing here, so we are check like once it has been incremented, we are putting the data into your queue. Till where we are putting that is it has to satisfy till this condition will come f equal to rar plus 1 or f equal to 0 and rar equal to. So f is pointing here, but rar will be pointing to the last location of your queue. Like I have taken 0, 1, 2, 3, 4. So size is 4. We can have the data till the location 4. So what is R equal to? Here, I have inserted already the element. So 3 will come, 4 here, and it is 5. So where rar is pointing? Rar is pointing here, and front is pointing here. So if it is pointing in this way, then f is equal to 0, r is equal to size minus 1, then already the queue, circular queue is filled. If it is not in this way, it may be f is equal to r plus 1. That is, I have deleted each and every, like it has been deleted and it came to a last position. Nothing was there. So it will be like r plus 1. F is equal to r plus 1. So if that is a condition, then only we can tell that it is filled. Okay. So if you have any doubts, you can ask me. In the same way, we are going to increment the F also. Please trace the program in the same way. So whatever I have done here, the size, increment the size, and you put the element, increment these things. And if you check in this way, you're going to get the, if you have any doubts, you can ask me. If you have any doubts, you can ask me. If you are not having any doubts, I'll thank you for attending the crash course. Here I'm going to wind up my session. Second session, like next session, will be starting from the like Nanta ma'am is going to. Nandita ma'am is going to continue with the next seventh program. See, clear screen. I got a question like clear screen is mainly we are going to use, and please remember once void main is over, you have to give the like declaration. Once declaration is over, you have to give the clear screen. Before that, if you are giving any function, it may show the error. Sagar, someone has been asked. So that has to be done. First, you have to check where, in which place you have given the clear screen. The clear screen function is used to clear the output screen to get a blank screen to your program. Whatever the program you're going to run, for that previous executed data should not be there. For that, you are going to use the clear screen. Okay, all 6 programs I have, I have explained you. If you have any doubts, you can like mail ID already I have shared. If you have anything, you can ask me. Next 6 programs will be handled by Nandita ma'am. Over to Nandita ma'am.
Oh, very good morning. Good morning, students. Am I audible? Good morning, Nikita. Yeah. So I'll be starting with the linked list program today. Today's agenda is to complete all the three linked list programs, that is single linked list, double linked list, and circular linked list, right? So before I start with the program, I will be just showing you an overview of the linked list, all the three linked lists with the variations. How are you going to insert the notes? How are you going to traverse the notes? With these concepts, we can go to the programs and then we can see how exactly it works, right? So I'll be showing you the program flow as well as the output of the program. I'll be sharing all these programs, which are small and simple after the crash course. Okay, I will just merge everything in one Word document or in PDF document and I will send you across. Right. So I'll be sharing the screen, students. I will be starting with the linked list today, and tomorrow we will be doing with trees, the hashing part, and the graphs. Right, three topics. So let me share my screen. Yeah, I hope you can see my screen, students. Fine. So let me start with this. So there are different types of linked lists, as every one of you know, because you've already studied this. We'll just have an quick overview of whatever we are going to study today. Okay. So we'll be starting with single linked list. That is a basic version of your linked list where you're going to study how to create a new node, how to add additional nodes, how to traverse through the nodes, and how to insert new node from the front, beginning, end, rear, deletion of the rows from the end and the rear part. Okay, front and the rear part. Fine. So let me go ahead. So these are the three types which you are going to study: single linked list, double linked list, circular linked list. And all of these three have a variation called as an header node. So there will be not much difference for it. The link concept of the linked list will remain same with an additional header node in the beginning of the list, right? So we'll be seeing all those things. Okay. So these are the basic operations which you are going to implement in your program also. You're going to insert a node from the front end and the rear end, delete a node from the front end and the rear end. And to do all these things, you also have to know how to traverse your linked list. Traversing is nothing but traveling from one point to another point till you reach the end of your linked list. Okay. So all these three basic operations should be well known by you people so that you can understand the flow of the program very easily. So how do you create a list? So before you start, doing all those basic operations, the first main important thing is how are you going to create the list? So you have to start with the basic list, right? So the first thing what you're going to do is you have to create a node, right? Linked list is nothing but collection of nodes. And what is a node? Basically, it's an memory space and where you're going to store the data. Okay, there are two things which you have to remember in linked list, that it contains address of the next node and it also contains the data. Okay, so this is very much different from your arrays, right? So as you have studied arrays, you must be knowing that even in arrays you are going to store the data one after another in continuous memory location, right? So similarly in linked list also you're going to store the data one after another, but here there is one additional thing which you are going to study, that is called as a link or a pointer which points to the next node. Okay, so this is what is it. So you can see here, this is the data and this is the link. This is basically the anatomy of your linked list, right? So you can see in front of you, this is a collection of the nodes one after another. So all my three nodes are connected one after another. Data link, here data and the link, and data and the link. And you can see the last node, you can see here, is marked as X because that means it is not pointing to any other node. That is, this is the last node or it is a null pointer. Okay, so this is what is written here. Basically, you can understand this as well as the diagram. You can relate it. So this is the anatomy, you can see here. This is how I'm going to show. This is my single linked list, structure of your single linked list, right? So this is a user defined name, whatever is given here. You can name whatever you want. So I've just given it as my list. So this is the name of my linked list, and the first node will be pointed by this pointer called as my list. Okay, fine. So this is a creation operation. How are you going to create a linked list? Now, basically, we are going to use structures as in data type to create a linked list, right? So you have already seen this, but still just an overview to make you understand the program. That's why I just have to go through all these things. So we need to create a structured data type, okay? And the node, what you're going to create will be of structured data type, will contain two members. One is the data and another is the pointer to the next node, that is the link. So this is how you are going to start with your linked list program, where you first have to define the structure for the node. What all structure you want, that is here. I just in data. So here it's not necessary that I should have only one data. I can have more than 2 or 3 data. How much of a data I want to store in the node. Okay, this is just an example, a single example where you are just declaring how to create a node. Okay, this is the first step. So suppose if I want to store the data of a student, name, USN, marks, phone number, email ID, whatever data, basic data of a student is needed, I want to store everything in a particular node. I have to declare everything here. Okay, so I have to say character, whatever character USN or int his USN, whatever data you want, you can give here. Character name and email ID, character name, string type basically. So all this can be given in this particular structure before you start with your program. So this was a basic thing. So now here, this is the creation of a node. So this is just a basic algorithm what is given here, how to create a node. You have to allocate a new node, then you have to insert a new element, then you have to first point that link or the pointer of that particular node to null, because this is the first time you are creating a node. So I cannot point it to any other node. So the first node what you create will have data as well as a null pointer, because it is not pointing to anything. Now, the next time when you're creating one more node, for example, you want to create data for one more student and you want to connect student 1 to student 2, that time I will make the pointer of student 1 point to the node of student 2. Okay, and the student 2 pointer will be null. So in this way, you keep on adding the nodes one by one, making the pointer point to the next node. Okay, and in the end, the last node pointer will always point to null. This is what you have to understand always. Okay. So here, how to begin? It's like you are, everyone are familiar with this malloc operation. What is in malloc? Basically, it's in memory allocation, dynamic memory allocation. So the advantage of having your linked list in the program, the major advantage is that we can dynamically allocate memory according to our need. For example, I have 100 students initially. I will create 100 nodes. Later on, 50 more students get admitted to first years. For example, after 2-3 months, they get admitted. Already the 100 nodes have been created. Now I need 50 more nodes to be created and have to be attached to the initial 100 nodes, right? So here comes the advantage of linked list, that they can be dynamically allocated. Dynamically in the sense on the fly. I want how much of a students, I can create it dynamically. So the major part here is I have to find the size of the node. What is the size of the node? It will give me the size that is actually required, the memory part. This is regarding the memory part, how much memory storage you want for this particular node. For example, if I am only storing the name and USN, I may require less memory compared to if I want to store the marks of the students, I want to store the USN, email ID, parent details, or student details. So that particular node will require more memory as compared to only the data which has only name and USN. So basically this size is nothing but finding how much storage you want. So, or how much memory this particular node will occupy. Okay, so this is the first step. So I'm giving a name called as temp here. Okay, so temp, this is a temp, this will create a node, right? So the first step was a structure. If you remember, I told you the first step, you have to define or structure for this particular node. Second step is to find out how much memory space is required for a single node. That is very much needed. So once I have done with this, then I can have this as a linked list. So this becomes my first node here. So I can have roll number, age, whatever you want, you can store here. And this part you obviously know it is an pointer which will point to the next node. Okay. Yeah. Fine. So if you can see here, if there are n number of nodes and how it is pointing to one after another, right? So this basically becomes your linked list. Right. So this is simple program which I have written here in front of you. Okay, how to create the linked list here. So you can see here, the first thing we have to understand how many elements you want to enter. Okay, so for example, I want to store 100 students information. So that particular number I'm going to use in this for loop. So everyone knows the working of for loop. So I'm just proceeding further. So based on that many for loops, that means it will work 100 times this for loop. And if you can see here, 100 times the node will be created. Okay, so in other words, 100 nodes will be created. Every time it's going to ask the size of the node and it is going to create an node here. Okay, after the nodes are created, in this for loop itself, if you see here, you are entering the data, that is roll number, name, and age. For each node, you're entering the data. Okay, and afterwards, you can see here, I'm sorry. So here, if you can see here, after everything is done, the last node will be pointing to null. Okay, the last node is pointing to null. Okay? So what happened here, basically, what was the operation? It happened, it created 100 nodes, which was linked one after another. Okay, and if you can see here, in the last, after this for loop is over, after creating the 100 nodes, I'm pointing the last node to null. Okay, that means it's a last node. I have already told the last node in the linked list will be always pointing to the null. Okay, so this is a basic linked list idea how to create nodes. This is all very much needed for your first program to understand how you create nodes. Okay, afterwards we will see traversing the list, that is going from one point to another point in a list. So what you have to do for traversing the list, always remember, you cannot start traversing in middle of the linked list, somewhere in the middle of the node. You have to always start from the beginning of the node. Okay, so always start from the beginning of the node. So you can always give a name to your node, whatever name you want, first, temp, head, any name as you feel. And starting from head, you have to traverse each node till till you reach a node where the pointer is null. Okay, so how do you conclude that you have reached to the end of the node? Basically, in a linked list, is that the pointer should be null. That means it is not pointing to anything. That means that you have reached to the end of your node. So I just wrote the points you can see here. Follow the pointers. Display the contents of the nodes as they are traversed, and stop when the next pointer points to null. Okay, so you just have to follow the pointers, and if the pointer is pointing to a data, that means you are not in the end of the list. So when you will stop, when the pointer will start pointing to your null. So these are the steps for your traversing list. So let's come to the first operation here. How to add node to the front of your linked list. For example, here in front of you, there is a linked list here. This is the first node. This now at this point, do not see what is this. This is the first node. This is the second. This is the third, and this is the fourth. And as I told you, so this is the end of my list because the pointer is pointing to null, right? So now what I want to do is I want to uh, insert this particular node here, okay, the beginning of the list. So that means I want this E, the data E to be before my data A. So what I'm going to do? So first thing is just forget about this now. Let's see what is it. So I have a pointer called as head, which is pointing to the first data. Okay, first data, right? So what I am going to do is, suppose if I want to insert the node, the newly created node here, I want my head pointed to point to this data. That is a simple thing we have to understand. So first whenever you read this topic called as adding node to the front, what is the first thing that should come in your mind is, what is the steps I should do? What is the step you can do is, the first thing is, whatever the pointer is pointing to the first node should be pointing to the new node now, right? So what should I do? And second step is that the new node link, that is the pointer of the new node, should start pointing to my this particular node. This is the two steps that are involved in this particular operation, right? So I want this particular node to get connected to this node, as well as I want my head pointer to get pointing starting to here, right? Simple. So this is how it will become. So what should I do? The new node, for example, say temp. I just give a name as temp, whatever I created. So what I'm going to do is temp of link. I will start pointing to my first node here. Okay, let us give a name called as first for this particular node, right? So what I'm going to do is, and let us give a name called as temp for this. So what I'm going to do is, temp of link, I will start pointing to first, right? Okay, then what I'm going to do, right? So my this two port got connected now. Now what is the second step that is remaining? This particular head, right, which is pointing to here, should start pointing to here. So I will name this particular node as head now. Okay. So I'll assign temp is equal to head is equal to head assigned to temp. So what will this become now? Automatically this becomes head. Okay. So that what is head in this particular operation? Head is the first node. Okay. According to our slide, head is the first node. So automatically this became my first node, and the link of this particular node started pointing to this particular node, right? So this became the second node now, and this became the first node. Okay. So as soon as you see this topic called as adding node to the front, imagine, or you can yourself draw a linked list. Okay. You can yourself draw a linked list and give some name that starts pointing here. Okay. And then you create a new node, right? And then start pointing here, and this pointing to here. With this itself, you can prepare your code. Okay, the code will be automatically generated by seeing the picture itself. So you don't have to by heart your code, or keep memorizing all these things. So draw a picture, give some names, and draw this particular things. So what happened here now? You just linked here to this particular node. Okay, so give a name for this, whatever name you want. Say first. So this give a second name for this. Say temp. I just told you. So temp of link, you assign it to first. Okay, and head you assign it to temp. That's all. So your code is ready, inserting node at the front end. So this is what you can do for your exams also. If you get confused somewhere, or don't no need to memorize any code, you just draw diagrams, give certain names, and with the help of this particular diagrams, you can write your own code. Okay, it's just matter of 2 or 3 lines. If you follow the flow. Okay, so now let the same thing, sorry, same thing, adding node to the rear end, right? So rear end is nothing but in the end. Now this is called as a rear end. This is the last node, so it is called as a rear end. So you have already heard in Q the name rear, right? So the end of the last node is called as rear end. So now what happens here? How are you going to connect this? Again, I've just told you, you cannot just directly go to the last node. You have to start your journey from the first node itself. So here the concept of traversing the linked list comes into picture. So you have to start from the first node, and following these links, you have to reach to the last node. So now the topic is to add node to the rear end. That means in the end here, right? Okay. So what is the 2 steps again you have to do is, the last node will be having a null pointer. Now, when you're going to add a new node to this last node, this will not remain a last node. So what you have to do, I have to start pointing this to the new node. Okay, I have to start pointing this to the new node, and I have to make the pointer of the last node as null. So these are the only two steps you have to do for adding node to the rear end. So it becomes very simple. The first thing is you have to traverse from the first node to the last node here by following this particular link. Okay, one after another, head of link. In this case, it will be head of link, head of link. Keep proceeding further, right? So you can give a name to your nodes. You can, as you have seen your books, in your books, they have used CUR. CUR is nothing a short form for your current node. So let us make this as a current node and let us loop in a while loop and keep jumping from one node to another till your CUR of link becomes null. So once your CUR of link becomes null, that means you have reached to the last node. Once you reach to the last node, my work is to now connect the new node to the last node. So I will remove this null pointer and start pointing here, right? And make the pointer of this last node as null. So that's all. So you have added the node to the rear end. Okay. So now that was your rear end. Now deletion or deletion of the node here, if you can see in front of you. If I want to delete a node, now here in this particular case, you have deleting a third node here basically. You can see in front of you, you want to delete the third node. So if you want to delete the third node, there should be a connection between the second node and the fourth node, right? So to keep track of the second node and the fourth node, I need two pointers here, two pointers, okay? One pointer which will keep track of the current node and another pointer which will keep track of the current minus one, that is the previous node to the current node. Okay, why do I require that? Let's see here. So let's see here, let's start from the first node. I will just mention, name it as CUR here for this particular node, and I will also mention PERV, okay, as null. Initially it is null, okay. And as I proceed further, this becomes my CUR, okay, and this will become my PREV, that is previous. Okay, so my previous node will be always one node behind my CUR node. So I keep jumping from one node to another node. Okay, so I want to delete this particular node here, right? So what I'm going to do is I am going to, this is my CUR here, or they have mentioned as TMP. So this is my previous nodes, right? So what I want is I want to delete this particular node. Before deleting, what should I do? I have to connect the fourth node, that is CUR link, which is the link which is pointing to the node should be connected with the previous node. So I'm going to connect my previous node link to the next node of CUR, right? So both these nodes will get connected, right? So previous link will be connected with CUR link, right? So, and I'm going to delete this particular CUR. Fine, would delete this particular CUR. To delete a particular node, we are going to use a function called as free, F-R-E-E. So free is a function which deletes that allocated memory, which was dynamically allocated. So this is how we are going to delete a particular node. The same operation you can do for deleting the first node, okay? Deleting the first node as well as deleting your last node. The same operation, if you can see, so the same thing. So this is my first node. If I want to delete the first node, what is the operation I have to do? I have to take this pointer and start pointing to the second node. And how I'm going to get the address of my second node? Through my first node. So the first link which is following the first of link here is this the second node, right? So I will start pointing the first pointer to this particular node and I will free this particular memory location. So my first node will be automatically deleted. Okay. Second thing is you have to delete the last node here. Similarly, to delete the last node, you have to traverse the linked list from one point to another point. Using the same concept, you have to give a name to your linked list, say CUR or the current, or whichever name you want, and keep hopping from one node to another node till you reach a null pointer, right? Till you reach a null pointer. Now I want this particular node to be, deleted, right? Sorry. Yeah, this particular node to be deleted. So what should I do? Before I delete this node, I should make this node as the last node, correct? I just can't, keep it as it is. So what I'm going to do, I'm going to make the node of the link of this into as null. Okay, I'm going to make the link of this is null. As soon as it is made null, so it's not going to point anything. So then I'll free this particular node by using the free function. Okay, so I've got my delete last node was automatically deleted. Okay, so these are the basic operations, student. These are the 4 basic operations which you really require to understand the first single linked list program. Okay. So I hope it's clear. Any questions here? Anybody has any doubts or questions? Can raise your hand or put it in the chat box. I hope the concept is clear. So shall we proceed further for the program? Okay, thank you. I'll just proceed further and I'll show you the flow of the program. Okay, before I show you this is the display method. A display method is basically used to show the contents of your linked list, right? Contents of your linked list. So I have a data which I need to, show you, show the display in the display method. So what I'm going to do is I'm going to start from the first node. So in this particular program, I'm also going to keep track of how many nodes are present in my linked list. So I'm going to initialize it to 1. You can initialize it to 0, then increment it to 1. It's up to you. How do you write your program? So I'm going to start with the first node and I have named it as head. Okay, and I'm going to proceed further while I'm going to check whether my P is not equal to null. P is nothing but the name that is given to a node and whether it contains any data. So if it is not containing any data, I'm going to stop my while loop. This is what it is. This is what is the logic behind this particular while loop. So P is not equal to null. Till P is not equal to null, I'm going to display whatever is there in that particular node, roll number, name, age, US, and whatever is there. And as I go and display the data, I'm going to increment the count. So what is this particular basically count going to do is give me the count of my nodes in the linked list, right? So I'm going to increment this, say it becomes 2 or 1 according to your initialization. Then I'm going to proceed to the next node. So P of next is nothing but you're going to proceed to the next node. Okay, so this while loop will keep on going on and on till my data becomes null. Okay, so this was your display method, very much needed for your programs, whatever the methods I have shown you now. So let's see the program. Okay. So before that, let me show you the demo of the program. Then let's come back to the program again. So if you can see right in front of you, it's a program where you are going to use the concepts what you have studied right now, right? And before also, it was just an overview what I taught you. So you have to create a linked list, you have to display the linked list, then you have to insert from the rear end and you have to delete from the rear end. And then you have to show demonstration of stack, that is insert front and delete front. In this particular program, you're going to enter the details of students. I'm going to show you the program also. Let me show you the demo. Screen is not visible. Sorry. Yeah, I'll just share it once again. Screen ಬರ್ತಾ ಇಲ್ಲ, stop sharing ಮಾಡಲಾ? You can see the screen, right? So I'll give you the demo. I'll enter data of 2 students. Okay. So here I have entered the data of two students. That means what? I have created two nodes, right? One after another. In a for loop, two nodes were created where it is asking me to enter USN, name, branch, SEM, and phone number, right? So, okay. Now, after this, again, you have got a menu where it's asking me what you have to do. You want to display, I'll display the data. You can see here. So right in front of you, you can see here, I've entered two students' data and it is getting displayed here, right? Okay. So if you can see here, it is insert front operation. If you are able to understand, students, it is insert front operation. That means you are inserting the nodes from the front end, because the first USN I entered was 1 and the next USN I entered was 2. And when I'm saying display, it is displaying 2 as well as 1. Okay. I hope you have understood. It is an insert front operation. So I have created the nodes by inserting from the front end. Okay. So let's take choice number 3 now. So our choice number 1 and choice number 2 is over. So I have created two nodes with USN 2 and 1. Now insert from the rear end. So now whatever data I will enter should come after USN number 1. Okay. So can't I? Give me a second. I just check with the screen part. Okay. So can't see it. So I've entered the data. So let me display it so that you can see. Yeah. So right in front of you, you can see the display operation where I have entered the data with USN number 3, and you can see it is inserting from the rear end, right? So you can see here, inserting from the rear end. Now I'll use the choice number 4, that is deleting from the rear end. Okay. So if I say 4, my USN number 3 data should be deleted, right? So you can see enter your choice for USN 3 got deleted with the name DF got deleted. If you want to display your data, you can just see. Okay. So now remaining data is USN number 1 and USN number 2. Fine. So, and the next choice is nothing but the same part what we did here, create, because the choice number 5 says demonstration of stack, that is insert front and delete front. It is similar to what we did here, right? Create data. We use the function insert front itself, but they exclusively wanted you to show the demonstration of stack as you have already seen. Stack is first in, first out. So insert front. So it will work similarly. So you can see here. So let's see it's at front. Okay. Let me take US number 4. Okay. Okay. So let me display it. Yeah. Fine. So then delete front. Okay, it got deleted itself. Okay. So the program here, insert front and delete front, it got inserted also and it got deleted also, the choice. Okay, so let me try once again. Push. You can see here, when I'm giving this choice number 5, according to this program, which I'm going to show you, there is a push operation. So yeah, you can see here, students, let's see here. Push operation, insert front. Okay, you can see USN number 6 was inserted, and then there was a pop operation also, which deleted the USN number 6. After deleting, whatever was the contents is displayed here. So this shows the operation insert front as well as delete front, just like stack. So that was your choice number 5. Okay, so this is the program, basically what you are going to do. Let's go to the program. I hope the output is clear, because it is similar to the output is clear. Whatever the operations we saw now, insert front, insert delete, delete front, insert rear and delete front, and creating and as well as displaying. Okay, let's come back to program. I'll just print a choice here. Okay. So right in front of you, I have a program which the output of which is shown to you people. So the program is to design, develop, implement a menu-driven program in C for the following operation on single linked list. Okay, so first part we did choice number 1, that is create a linked list of n students data by using front insertion, right? And then display the status of linked list and count the numbers of nodes into it. Perform deletion at the end of the linked list and perform insert deletion at front of single linked list. Okay, this is demonstration of stack. So we'll be having 5 choices, 1, 2, 3, 4, 5 choices. Out of this, you have to do all the operations which we saw now. So the first step, students, what you're going to do is you have to define your node, right? So this was the first step, as I've already told you. So since we want all this data, you have to create this data members, structure members, right? And then this is the important part where you have to create the link to the next node. Okay? And type def is a name given to an existing data type, right? Because of this type def, I'm going to use this node, node in capital letter everywhere, right? So this is a node that is going to be created. So I'm going to use everywhere this node instead of using this structure node anywhere. Okay, so now after you do this, what you're going to do is you are going to have this basic operations, that is insert front, you're going to have create, delete front, and you're going to have insert rear. Okay, delete rear, 5 functions here basically, and you are going to have display, right? So the first step, what we are going to do, this is a main program, right? This is the main program where you're going to create, display, insert rear, delete rear, demonstration of stack, which you already saw. And I think it's the reason I showed you the output first is so that you can get familiar with the program. When you see the program, you'll understand what exactly happened. So these are the menu choices. Based on this choice, that particular function will get executed. So case 1 is nothing but create. Second is display. Here it's insert rear and here it is delete rear. And case 5 was demonstration of stack, where you're going to use this function insert front and delete front. Okay. So one by one, let's see the functions now. So the first thing is create. You're going to create the node, right? Create the node. How are you going to create the node now? Right. You're going to ask how many students you want to enter the data. Based on that, you're going to call this function insert front. I just told you by default, I'm using insert front as the basic operation. That is, I'm going to insert the data before the, one before the another, not after. Okay, so insert front. So what is happening in insert front here? You can see here, you're going to first create a node. So this is the obtaining a new node, that is creating a node, and each node you will be entering the details of the student, USN name, branch, SEM, phone number, you can see here. Okay, so this is how you are going to enter the data first. As you keep on entering the data, you're also going to increment the count of the data. Count of the data. Why? Because you want to see how many nodes are there. So I'm going to increment this count. Okay. So for each for loop, which is there here, for each for loop, okay, insert front function will be called. If I have 10 students data to be entered, 10 times insert front will be called. You can see here. 10 times insert front function will be called, and you're going to enter 10 data. Each node will be linked to each other. Okay, so this was a creation of your node. So if you can see step by step creation of your node. Then what you're going to do, the next function, let's go for insert rare. So this was a function choice number 3, I guess. So here you're going to enter a new, first create a new node. Okay, and this is how you're going to create the new node. This is a normal method where you're going to create a new node and enter the data. Then you're going to link it to null, because I just showed you in the PPT itself that the last node should always point to null. Last node should always point to null. Okay. Then after this is the last node, so you're pointing it to null, right? And then here, this is the loop. I just told you, just cannot traverse the nodes in the middle, somewhere in the middle. You have to always start from the first node, and then till the last node becomes null, you're going to keep on traversing the linked list, right? So when you reach to the end of the linked list, okay, you are reached to the end of the linked list, then you are going to insert the node here, the new node which you have created here. Okay, so now written first is nothing but returning the address of your first node. So in this particular program, the first node is being addressed by name called as first. So here when you are returning first, that means you should always return the address of the first node to the main program, because always any linked list program, the traversing part or any operations always start from the first node, right? Now, delete rare is I have to go to the end of the linked list and delete the last node. So what I have to do, again, I have to traverse from the first node till the last node. Okay. I also told you, you have to have 2 pointers here. One pointer which will always point to the current node, and another pointer which will point to the previous node, so that I can keep track of the previous node also in this, because once I reach the last node, I have to delete it. Before deleting, I have to make the second last node as the last node. So I have to make it as null, right? So I need to keep track of the previous node also. So this is where you can see you have something called as previous here, and see in this while loop. Okay, every time I'm going further, have a current node as well as I have a previous node here. Okay, then I'm going to come here and I'm going to free your current node, that is the last node at this point, and then the previous node should be made as a last node with this particular statement. Okay, so if you can see, I have commented everything here for your understanding, better understanding. So you'll understand what is the need of this. So this is how it is. Okay, and always return the first node. Now you have to display. I've already shown you how to display it. You have to start from the first node till you reach the last node, and then you have to keep displaying it. You can see here display method. If the first node is null, that means it is an empty linked list, right? So you can mention in this if statement, check for an empty list. And if it is not, then you have to start from the first node. Have to check whether it is null. If it is not null, then you have to print it, right? And proceed further. What is this particular thing doing here? You are going to traverse. This is basically traversing the linked list, right? Okay. So this was the basic program, students, inserting and deleting from the front as well as the rear end, also to demonstration of your stack. Okay. Any doubts in this? Anybody has any questions? Abhishek Kumar, you have any questions now? Abhishek Kumar, I think you had asked me, can you tell algo for insertion or deletion? You have any doubts now? Okay. Repeat the whole program. Should I repeat the whole program? Or should I show you the demo? Insertion and deletion. Demo. Okay. Okay. Let me come first to the program. So I hope you're clear with the first step, that is creating the linked list, right? The first step obviously is the definition of your node. That is very much important. This is how the node is declared, right? And then we'll go to the basic operation, that is creating a linked list. Now, how to create a linked list is nothing but inserting the nodes. It can be from the rear end or it can be from the front end. So here in this program, I have taken it from the front end. So how many nodes you have, based on that, based on the number of nodes, that many times this function will be called. So what do you mean by this function? That is insert front. Insert front is nothing but it is connecting the nodes from the front end. So if I have 10 students here, 10 times this function will be called and 10 nodes will be connected one after another. So every time this particular function, this particular malloc function will allocate that much memory space and it will name it as temp. Okay, temp. Here you're going to enter the details of the students and here you're going to increment the count of that particular node. That means if I have 10 nodes, the count will be 10, right? So 10 nodes connecting one after another. And how is it getting connected? This is how it is getting connected. Okay, so initially your first node, when you create a first node, it will be pointed by something called as first here, which is initially null. Later on, once the first node is created, the first will start pointing, right? And then the second node will created, the first will be, or second node will be created, the new node, it will be called as first. Then the third new node will be created, that will be called as first, because this is an insert front operation. As I'm talking, you should also try to visualize, okay? Or I can only do is annotations here. So this is my node here, okay? So this is pointer, again one more node, insert front, okay? One more node, okay? This is one more node, keeps on happening, okay? And every time this happens, this becomes my first, okay? So I'm going to give it a name as first. First, for the very first time, this was first, okay? Second time, this was pointing by first. Third time, this will be pointing by first. So you can see here. Okay, you can see here. First. Right? Okay. Now, so this becomes my creation of nodes, inserting from the front end. Now, suppose if I want to insert from the rear end. Now, then what I should do here is, I have to start from this particular node and I have to come till here, right? So here I am going to use a while loop, which will take me from this node to this node, right? How I'm going to go from this node to this node? With the help of this particular pointers, right? Without that, I cannot go. So for inserting from the rear end, first thing is I have to have a node here. Okay, a new node. So this is done here. You can see new node. This is a new node. Okay, they have named it as temp. They have named it as temp. So I'll give it a name as T. Okay, so fine. Now what I'm going to do, I'm going to enter the data. USN numbers, name, branch, everything will this node will contain, right? Now what is my job? My job is to insert from the rear end. That is, I have to connect this node with this node, correct? And I have to make the link of this node as null. I have to make the link of this node point to this node, and I have to make the link of this node to null. Okay, this is my job. So before I come here, first I have to start from the first node. Okay, so let me name my first node as CUR in this, according to this program, students. Okay, let us go from this program point of view. So this becomes my CUR. So first, you can see here first. Okay, I'm assigning it to CUR. So this becomes my C. Okay, I'll now try the whole thing. So this is C. Now what I'm going to do in this while loop, students, just see here, I'm going to traverse from one node to another node, right? How I'm going to traverse? With the help of this link. And till what I'm going to travel? I'm going to travel till the link becomes null. Okay, so at this point, this link is null, right? At this point, this link is null, right? Okay. So I'm going to start traveling now. I'm going to travel. I'm going to traverse to the while loop. Okay, one by one. So my C initially was here. Now I'm going to here. I'm going here. So finally my C has come here. End of the while loop. Okay, end of the while loop. Now what I'm going to do here? Okay, CUR of link. I'm assigning it to temp. That means this link. I'm assigning it to temp. Okay. Okay, so this link was null now, it became temp, right? Now what I'm going to do here afterwards, what is going to happen? Okay, I'm going to increment the count because new node has come now, right? So automatically this was already null. So you can see here very first time when you create a node, it will be always, the link part will be always null. So I don't have to exclusively do null here. So this is already null, okay? The only job what I had to do is connect the link part of this CUR with my temp. Done. So my insertion from the rear end is over. Okay, that is done. Now, second thing I have to do is deletion from the rear end. Deletion. How do I do deletion from the rear end now? Okay. Now, if I want to delete from the rear end, that means what I have to do? I have to keep the track of this node also, because the link should be pointing to null. Okay, now this is the scenario. I have to delete this particular node, and this particular node link should be made as null. So similarly, whatever we did for insert red, first thing is I have to start my journey from the first node here. Okay, journey from the first node, and then I have to keep coming to the last node. Okay, Abhishek, where is the head in that insertion? Header nodes, I'm not talking about header nodes. This is simple singly linked list without header nodes. Abhishek Kumar, for your information, I am doing a program without header nodes. Okay, now, so I'll start my journey from the first link, first node till my last node here, right? So this is my CUR. Also, one more pointer I have to keep track now, that is previous, P. Okay, previous. So as I come here, this becomes my P. I'll just rub this. Okay. So as I come here, this becomes my P, right? Okay. So as I come here, this becomes my P. So this way, I'm reaching a point where I'm coming here. This is C and this is P. Okay. Now this becomes my P and this becomes my C. Now what should I do? I want to insert this, delete this particular node, right? So what I'm going to do before I delete, I will make this link as null. Okay. So I'll make this link as null, NULL. So you can see here in this particular program. Okay. Just scroll down. Yeah. You can see here. Yeah. I'll make this link as null. Okay. And I'll free this cursor. Sorry. Okay, so this is free. That means what happened? This node got deleted. Okay, and I decremented my count so that instead of 4, I should get my node as 3 now. Count as 3, right? So this was your deletion from the last node. So just if you can follow the diagrams, and then you can write the code on your own if you know what to do now, right? So any other questions? I hope, Abhishek, I've cleared your doubts. Right? Okay. So this was a simple single linked list program. Okay. So basically, students, you just have to understand that you have 4 basic operations plus 1, that is traversing your linked list, which really forms a major part. Because if you want to delete a node or insert a node from the rear end, traversing a linked list is a must, right? And I have also told you when you have to use 2 pointers, the why you have to use 2 pointers to keep track of previous nodes, to keep track of the front node. So you automatically will get an idea how to write the code. So all these things, this is basically for the traversing part. So you can understand now. So without memorizing, without by hearting the program, drawing a simple diagram itself, you can write your code on your own. Okay, so this is what I wanted to convey. Make things easy for you people. I'll share this particular program with you also with all the comments in it, so that you'll understand what exactly it happens. Okay, follow the steps. Programs are not that difficult. Okay, if you feel that it is too lengthy, that's because you are not understanding the concepts. Okay, understand the concepts. Programs are not at all difficult. Okay, so any more questions? Yeah, Abhishek, yes, you can use header node. Header nodes can be used for all kinds of linked list. It can be used for single linked list, it can be used for doubly, it can be used for circular also. Since this particular program was exclusively for only simple single linked list, it's explained that way. Okay, Abhishek? Fine? Yeah. So you have one more program where you are going to use circular linked list with header nodes. That is your polynomial program if you have executed it. So that there the picture of header nodes will come. Okay. So since this was not with the header nodes, so I just gave a simple program. You can execute this using header nodes also. It should not be a issue unless and until you get the output. Okay. Fine. So shall we proceed with doubly linked list or shall we take a break? Abhishek is the first to answer. Okay. I'll just stop the session with a demo, with the same program demo. Somebody wanted the demo. So I'll just show you the demo once and I will stop the session. Okay. I'll just. Yeah. So enter data of students. See. Right. So USC number 12, USC number 13. So now I'll just show you choice, enter your choice, display. You can see here, USC number 13 and USC number 12 is here. Okay. So insert from the front end. And now you want to do it from the rear end, you can give choice number 3. So I'll give insert number 15. So it should come after USC number 12. Okay, display it. So you can see here USC number 15, right? Yeah. So now next one is delete rare. If I say delete rare, the USC number 15 should get deleted. So you can see here student USN 15 got deleted, right? Now if you display it, only 2 USNs will be remaining, 13 and 12. Now if you want to insert from the rear end, again, sorry, delete it. Okay, I will show you the demonstration of stack. Okay, USN number 16, name, some name. So you can see here push and pop operations here. You can see stack is first in, first out, and whatever USN I inserted, that is 16, came in the topmost. that is insert front, if you can see here, right? Push operation. And pop operation happened. That means the USN 16 got deleted. So this is the 2 that is remaining. I hope you have understood it, students. Let's meet at 1:30. Okay, the next session, I will be explaining you doubly linked list as well as circular linked list, the polynomial program. Okay. Okay, we'll meet at 1:30. Every one of you, please join the session at 1:30. Thank you. Shall I start the session? Yeah. Okay. So we'll continue our session with the double linked list program, right? So before that, I will let you people know what is doubly linked list. Let me go back to my slide. So now since you are familiar with the single linked list concepts, so let's come to doubly linked list. So since you're familiar and now your basics are quite strong enough to understand the linked list concepts, here there will be a slight change. So if you look at the picture itself on the screen, you can see that uh, you have two pointers here. One is which is pointing to the forward node and another which is pointing to the backward node. That is our doubly linked list, we will work from forward as well as towards the backward also. So I can traverse the linked list through in both the sides, from the front side as well as from the right side also. Okay, so here this is the major difference in your doubly linked list. There is quite a lot of applications of single linked list which I forgot to mention in the morning. Actually, if you see linked list can be implemented as a stack, it can be implemented as a queue, it can be implemented in your hashing tables. If you have already studied hashing, which we will be doing tomorrow, you'll be understanding how linked lists are used because all of your hashing programs use linked lists. So a lot of applications of linked list, we ourselves saw the applications where we use the linked list as a stack itself, right? So it was working as a stack. So I don't have to write a separate no, stack program for that. I can use my linked list itself, which works as a stack. So in case of when you come to doubly linked list, a very beautiful example I can give you is your music player, where you can have your list of songs stacked one upon another, right? And then you can move the songs forward as well as in a backward direction also. If you can give this example. So the music player uses the data structure doubly linked list. So I can forward the songs, I can rewind the songs, I can go to the first song, I can go to the last song. So this becomes my traversing, right? Going to the first song, backward direction, going to the last song, forward direction. So I am using the concept of doubly linked list. So your music player, there are a lot of applications of doubly linked list. One of the application I just mentioned because you can, relate it very easily. That's the reason I mentioned about doubly linked list. Okay. So in front, right in front of you, you can see the doubly linked list diagram, which is showing you two pointers. One is the next pointer it's mentioning, and one is the previous pointer. So it becomes very easy for us to traverse in a backward direction because of this pointer. So all your programs will have little change here. The program will remain same as your single linked list, but there is a little change here because you also have to take care of this previous pointer, right? When you're, for say example, I want to delete this particular node, right? So I have to take care, that this particular link should be um, mentioned as null, and I have to also take care of this particular pointer also. So if you want to delete any node in this particular linked list, I have to take care of both the pointers. Similar case, if I want to add some node into this particular linked list, again, I have to take care of both the pointers. I have to see that both the pointers are pointing to in the right direction also and to the right node also, right? So the work increases here because in single linked list, you don't have to worry about the previous pointer. You just had one pointer and you used to take care of this one pointer. Now, only thing is the lines of codes will increase here because you need to also take care of your previous pointer. Okay, so this is how it is. So just an idea again. So you can name anything for this pointer, next, previous, first, last, whatever you want. Okay. So here, just an idea how it works again. You want to add a node to the front. We'll just take all the basic operations again. but only to see that here you have to take care of your previous pointers also, right? So just for your idea, I want to add a node to the front. So just forget about this particular node now. This is a new node. This is my doubly linked list initially. So if you can see here, these are my pointers, front as well as backward pointers. So here, if you can see, the backward pointer of the first node is pointing to null. Okay, just understand the backward pointer of the first node is pointing to null, and the last node will not have any backward pointer. And here, if you can see, this is null, as in the case of your single linked list, similar to your single linked list. So if you can see here, the backward pointer of the first node is null, and the first the forward pointer, that is not a forward pointer, basically it's a pointer. First node should be pointed by some other pointer, so any name you can give. Head, don't get confused with the header node here. This is not an header node, this is a name given to the pointer. Okay, so I am not touched up the header point till now. So this is a name, you can name it as first also. Okay, you can name it as CUR also, it's up to you, it's a user defined name. So here they have named it as head, which is pointing to the first node. And if you can see, this pointer is pointing to null, indicating it is a first node. Okay, so this is the major difference which you will not find in single linked list. This is the major difference. Other things I told you, only difference is you have a backward pointer in all the nodes, you can see, right? So now if I want to insert a new node here, what is the thing I have to do? I have to have two pointers, one thing. The second thing is the previous pointer of the first node. Note my point, the previous pointer of the first node should always be null, right? So what should I do? I should remove the previous pointer of the first node, right? The first node which is already there, and start pointing to the new node, right? So this is what is happening. Can you see here? Start pointing to the new node, right? Okay. Now the next pointer, very obvious, it will point to the next node, right? So this is a major difference. The null pointer, which was a null pointer of the so-called first node, now is pointing to the new node. Okay, new node. And the next pointer of this new node is pointing to the first node, okay, of the old linked list, not the new linked list, because now this is the first node, right? Now the first node previous pointer will be marked as null, right? Because this is what we have understood by now, that the first node of the doubly linked list pointer, the previous pointer, will always mark to null. And very obviously the head or the first pointer, you can name it as head or first, whatever you use the name in your program, maintain it across the program. So if this is head or if this is first, it should start pointing here, right? So what does it means? It means that this has become the first pointer now, and this has become the second, sorry, this has become the first node now, and this has become the second node. Okay, so this is how it works. So that the only thing is the line of codes which you are going to write will increase 2 or 3 lines, because there is a concept of previous pointer here. Okay, so simple, you can see, you can name this as any temporary node, right? So temporary node will start pointing here, temp of next will start pointing to the first, which was initially first, right? And first of previous will start pointing here again, okay? And the temporary node previous will start pointing to null, okay? So this becomes my first node and this becomes my second node now, right? So two things you have learned here. First thing is the overall doubly linked list concept. That is, there are two pointers. One is which moves in the forward direction, and another is which moves in the reverse direction, right? And then the first node previous pointer will point to null. This remains same. There will be no previous pointer here. This will be null, indicating this is the last node. Okay. Now this is what, then if you want to insert a node here, new node in the front, in the beginning of this, the two steps you have to follow is first to make the previous pointer as null. So that indicates that it is becoming the first node. And the next is the previous pointer of this node, which was a first node now, will start pointing to this, right? And the next will start pointing to this. Okay, so this becomes the doubly linked list concepts, adding node to the front. Okay, we are going to see all these codes in the program itself, because your program which you are going to execute for your lab program will have all these functions. Okay, so we will see the same concepts which you are seeing now and I am making you understand will be written in form of a code. Okay, so first now understand the concepts, then we will see how actually you are going to implement this in the code. Okay, okay. So now we'll go to the next slide, now to the end. Add node to the end. Okay, so same concept, you are adding or inserting node to the end. So same concept as your single linked list. Assume that this is your doubly linked list, is already there. Null, you can see the first node has this null and this is pointed by head, and this is your last node, that is null, right? So now the as your single linked list concept, if you want to come to the last node or if you want to traverse through the last node, I have to start from the first node. In a while loop, you're going to check whether your next is null or not. Yes, if it is not null, you're going to keep traversing till you reach a point where your next node will become null. Okay. So now when you reach a point where your next has become null, that means you have reached to the end of the linked list, right? So now we want to add a node to the end of the linked list itself. So first job is to create a new node by using a malloc function, which we have seen in the morning session itself, right? So using a malloc function, we are going to create a new node. And now I want to append this node to this, right? How I'm going to do that? The first job is that since I want to make this node as a last node, first thing is I have to make this as null because it is not pointing to anything. As soon as the node is created, a new node is created, by default, we always make the link as null. So you don't have to write an extra line of code for this. Okay, so if you can see your program, linked list program, as soon as your node is created, by default, the link is always null. Later on, it is linked with another node, right? By giving the name of that particular node. Now it is null, so no need to write an extra line of code. It is already null. Only job we have to do is we have to connect the forward link of this particular node, which was the last node before, to this particular node, saying that there is one more node available here, right? And since it is a doubly linked list, I should also have a backward node, right? Backward pointer, which starts pointing to the second last node now, right? So this is the two extra things which we have to do. Only 2 lines of code, students. Other things, everything remains like your singly linked list. Okay, so what is there? What was there in the singly linked list is to just come here, hop here, and come back here. Okay, using a while loop, you have to just come from the first node to the last node. Then what you have to do? That becomes you have come here. Afterwards, what you have to do? You have to take this null pointer and start pointing to the new node, newly created node. And you have one more extra line of code, which is this backward pointer. Okay, so which will start pointing to the second last node. So in this case, just like your single linked list, you have to maintain 2 pointers. One is the current pointer and one is the previous pointer. Okay, so just like that, I had shown you in that particular diagram also. I'll just start doing that. So this becomes my current and this becomes my previous. Sorry, I'll just stop this. Okay, so let me just, so this becomes my current initially, say, okay, so this is my C, okay, this is my C. Okay, yeah. So what happens here? I have one more pointer called as P, right? Previous. So current pointer will keep track of the current node, while previous pointer will keep track of current -1, that is previous to current node, right? So if I am in node B, so my previous pointer will start pointing to node A. If I am at node C, my previous pointer will start pointing to node B, and so on. So this will keep on going on and on and on, right? So to keep track, because I need to, make this connect here, right? That's the reason we need 2 pointers here. So previous, current, and so on. Okay. So now this was the concept about your adding node to the end. Now let's see the program. Let me show you the program. Okay, the concept remains same. Let me show you the program, how it is written, how to traverse, how to insert the node, how to delete the node. One by one we will see. Okay. Okay, so want to see that, I'll just show you the demo first. Need to share the screen. 1 second. Yeah. So you have a program similar to your single linked list, where you have to enter the details of employee. Unlike your single linked list, it was students. So you have to enter the employee details here, and you have the same basic operations where inserting the node in the front end, deleting the node from the front end, and so on. You can see the same basic operations. The only difference is the program, how you write will be different. We'll come back to program again. So we just see this output. Okay. Take 2. Okay. So I have entered the data. Now your choice. You want to display the data, you can display and see how it is looking like. So this is how it look like, right? So 121 and 122. So here it is using the concepts of insert from the rear end. Okay, inserting from the rear end. So you can see I entered 121 first and 122 later. Okay. So now if I want to take the choice number 3, that is insert from the rear end again. So if I'm entering one more data, it will come after this. Okay, so let me enter the choice 3, 123. Okay, so it's done. So display. So you can see here 123, right? Fine. So let me enter the choice number 4, delete end. So if I'm saying delete end, so this particular data will be going on. So what I'll do is I will use this choice number 5. 5. Okay. So insert front. So I'm just going to enter number 120, say CSC. Some. Okay. Okay. So now if I want to display the data, you can see 120, 121, 122, and 123, right? So insert front. Now I will just delete end, that is one data number. This particular data will be going deleting now. So you can see here. Oh, I did choice number 6, I suppose. Delete front. So delete front is this. So this got deleted. Now if I'm doing choice number 4, so this is the data that got deleted, right? So if I'm displaying display now, so this is the data that is remaining. Fine. I hope you have understood the demo, because it is a simple demo similar to your single linked list. Let's go to the program, back to program, and see what additional details we have to put for you for your doubly linked list program. Okay. So just come out. So just show you the program. So you can see here, this is the program here, program number 8. Design, develop, implement program in C to create a double linked list of n employees using end insertion. So they have explicitly mentioned here that you have to insert from the rear end. Okay. If they are not mentioned, you can use insert front end also, but they have actually mentioned here. So you have to use insert rear. Then you have to display. Then you have to perform insertion and deletion again at the rear end, and insertion and deletion at the front end. Okay. Okay. Now just see here. This is the data which you have to enter. So now if you can see, this is the additional data, right? So I'll just show you what is the additional thing you are doing in this particular linked list, doubly linked list, that what additional apart from single linked list you are using. So in single linked list, you had only one link. Now you have two links, one which is the next link and one is the previous link. Okay. So this is the additional thing which you are going to do, that is right link and left link. We will call it as right link and left link. So it's easier for us to understand. Left link is nothing but towards the backward direction. Right link is nothing but towards the forward direction. Okay. So this is the definition of your node, structure node. So once you create an type def variable node, then you are going to use this in your program, overall program, right? So now, initially your node will be null. Your count is 0. Count is to keep track of your number of nodes. Okay. Now, this is the data you're going to enter, and this is the variables which you have defined here, right? So as you see in this program, you have again 4 functions, basic functions: insert end, insert front, insert rear, and delete rear and delete front. Okay. So the first thing, I'll just show you the menu part. As you have already seen in single linked list, the menu part, you're going to have 5 menu part here: create, display, insert and delete, insert front, delete front, and exit. Okay. So these are the main functions. Let's not concentrate how the program works, because you have already seen the demo. So you know how it works basically. So let's see the function part, how it exactly works. So insert end, and insert front. So let's come one by one. So first you need to create the linked list. First you need to create the linked list. So let's go to the program create function here. Okay. So what are you going to do here? You have to go to enter the number of employees. Depending on the number of employees, you're going to call this function insert end. Okay. Unlike your single linked list, insert front, you are going to do it from the rear part now. Okay. So insert end. So depending on the number of your employees, this function will be called that many times. So insert end. So what are you going to do in the insert end here? Okay. Let's see. So first, this part will create a node. It will allocate a memory space for the node. So everyone knows, as I told you, malloc is dynamic memory allocation, which will take the size of this particular structure according to the data type, and then it will allocate that many memory space. Okay. So temp is a node that is created here. Temp is a node that is created of this much memory space needed. Okay. So now after the memory space for the node is created and the node is created, you are supposed to enter the data, right? So what data is required? All the employee data will be entered into that particular state with this statement. This is where you are going to enter the data into the node. Okay, so this data is entered, and for the very first time, your left link and your R link, that is your previous link and your front link, will be initialized to null. Okay, so now if this is null for the very first time. By default, I had already told you, whenever a node is created, the links are initialized to null. Okay, now if this is a very first time, if it is null, that is it's the very first time when you're creating. If there is, the linked list is empty, if the linked list is empty, then you are going to count plus plus and return temp, that is it will return only first node. Okay, so nothing is there in the linked list. Now if it is not there, if it is not, then what you are going to do is, this is the very first time when the node is created. For the very second time, this part won't work. Okay, now else part, what you're going to do is, you're going to, so for example, now this is the second time I have created a node. Now you're going to append the first node with the second node. Okay, the first node is already created. The scenario is that the first node is already created. Now you're going to, the for loop is working for the second time. The second node is created. Now you're going to link it, right? You're going to link it. So if it is not equal to null, then you're going to link it with the right link. So we are going to link in a forward direction. So I'm going to obviously link it with the right link. Okay. So this is how it is going. So this is the extra thing what we have to do. This is the extra thing what we have to do, students, if you can see here. Okay. So this part is where you're going to link one node with another node, whereas you're going to connect the previous pointer with the previous pointer as well as the forward pointer. So this is the main logic where you're going to connect that. Is it clear, every one of you? Okay. So this was from the insert end part. So what is happening here, I just told you, you're going to link it to from the first node to the second node. For example, this is a second node I have created. Now I have to join these both nodes, right? So this is the logic where you're going to join it, okay, or append it one after another. Okay. Now here we have to take care of two things. As you are doing a doubly linked list program, you have to take care of your left link as well as you have to take care of your right link also. Was that clear? And why is this right link is equal to null? Because at this point, if I am having only two nodes, the second node the right link should be made as null. Okay. Okay, assuming that this is my second node. Now, if I'm adding one more node, okay, so the same program will work. Everything, all the data will be entered. Now, this won't execute. I'm going to come to the else part, right? And then I'm going to check whether my right link is not equal to null. Okay, if it is not equal to null, I'm going to do this, right? And then I'm going to connect a third node with the second node now. Okay, as I keep on connecting, my right link should be null always, because that becomes my last node. So understand that the right link should become, the last node should have the right link as null. So this is to make it as a last node. So this loop will keep on going on and on till you keep on, calling this function. Is it clear? Okay. So now this was your insert end. Now this will become your insert front. The same logic again, same thing. But here now what we have to do, as we know that, let's see here how it works. So I have a node here. Okay. So I have to insert a node from the front end, right? Correct? I have to insert the node from the front end. Okay, then this is what I have to do. What is the thing I have to do? This is my node, this is null. I have to make this point here and this point here, right? This is all. This is what we have to do. So initially assume that this is the only node we have. This is the only node we have. Okay, and my first node is pointing to. I'll just say this. Yeah. Okay. Assume that there are two more nodes here in the back end. Let's do that. Sorry. Okay. So I have this. Now, since this is my first node, this will be pointing to null, correct? This will be pointing to null, right? Yeah. So if you can see here, students, just see here. Yeah. Temp of left link is null. Okay. Temp of R link is pointed by first. Fine. So now, yeah. So this is how it happens, because if I'm entering a node from the to the front end, I have to make my temp. This is my temp. This is my temp. Okay. So temp of left link is null. So this becomes null, right? Right. And temp of R link is first, assuming that this is first. Assuming that this is first. So when you create a node, assume that this is the first node and this particular node was not available. I want to append a new node now in the beginning of my beginning of the linked list. So what should I make now? This I have to make the left link of this node to null. I'm sorry. Left link of this node to null, which is done here at this point. Okay, so this is done null, and my right link should start pointing to first. Right, my right link should start pointing to first, and the left link of my first should start pointing to temp. So can you see here? This is what it is done. Okay, so these three statements, what these three statements will do, these three statements will automatically add the new node to the front of the linked list, doubly linked list. right? So again, I will repeat. Assume that, okay, I'll just show you once more these three statements. Assume that this is the first node. Okay, this is the first node. I'll just erase this and I'll just go with the flow. Okay. Assume that this is the first node, right? I have some data in this. Now I have created a new node. Okay, this is the first node. I have created a new node and the name of the new node is temp. Name of the new node is temp, right? Now what I'm going to do, I will enter all the data. Now what I'm going to do, I want to make this as the first node. So what I'm going to do is I am going to make this link as null. So this is the statement which you can see here, right? This is the statement, same statement which you can see here. Okay, fine. So after this, what is the next step? Next step is I have to make 2 pointers here. It's a doubly linked list, so 2 pointers. One will be for pointing here and one will be pointing to the backward side. So see here. So you can see here the next statement, temp of R link is equal to first. Okay, so temp of R link is equal to first. So this is my right side. So point it here. Okay. Now temp you are assigning it to first of left link. Okay, first, this is the first left link assigned to temp. Okay, so this becomes my insertion from the front end. I hope you are understanding it. This becomes my insertion from the front end. That's all is the code, students. You just have to visualize how exactly it works, the pointers, and within 2 or 3 lines of codes, you can finish your program. Okay, the function, basically what I meant is the function. So for each function, if you see, there are only 2 or 3 lines of codes which you yourself can draw a linked list diagram and draw these pointers, give certain names, and then finish the codes. Only these 3 lines. These 3 lines and wonders are done. Okay. Okay, so that was your 2 functions, insert front and insert end. You saw how it worked, and there are only 3 or 4 lines of codes which will make the code work, right? Now the similar create, we saw delete front, delete front. Let's see delete front now. Okay, so I'll just erase this. Okay, delete front. So assume that you have a linked list. Let's see. Okay. Yeah, this will point to null. That's all right. So if I want to delete this, what should I make it is? Only one single thing is that I have to make this pointer as null. That is what is needed here basically, right? Make this pointer as null, and I have to forward it to some and it start pointing to the next node. This is what I need basically. So I want to delete this basic pointer, right? So let's see how it works. Let's see the code. Okay, so this is checking whether the linked list is empty or not. So it is checking whether first node is empty or not. Basically, we name it as first here. According to this program, this is named as first. Okay, and also they have given the name as CUR because I want to delete it. So I have to maintain this because once I delete this particular node, the second node becomes the first node, right? So I need to rename this. That's the reason I have taken one more name here. Okay, so when I delete this, my first has no impact. Let's see how it works. Okay, so now what I'm going to do is, this is my CUR, this is my current node, as well as this is my first node. I've given a alias name for it. Let's see why. Okay, now this is what I have done here. If you can see here, CUR is first. So both are here pointing to this particular node. Now what I'm going to do is first of R link. Okay, first, this is my first R link. This is my R link. So again, this becomes my first now. Okay, so this is gone. I hope you're understanding this step. This becomes my first. Okay, now what has happened? First of left link as null. First of left link is null. So this is my left link, students, and now it has started pointing to null, not this. Now it has started pointing to null. So this has gone. That means, okay, or you can tell it as pointing to null. That means what? when a left link of any node starts pointing to null, that means what? That means it becomes the first node of the list. Okay. Now easily I can delete this node by using the function free. Can you see here, students? Here, free CUR. Okay. So easily I deleted CUR, right? So now what happened in the list? The first, this node is called as first. That is the reason, if you see, we have assigned it this way. Okay, why the alias name is required? That is the reason, because you are ultimately going to delete this CUR once you have joined that link and made this link as null. So these are the two statements where you are going to delete the node from the front end. I hope with this diagrams you are able to relate how this code works. Am I clear, every one of you? With this diagram, is it are you people able to understand? Okay, assuming that you have understood. Okay, so I hope we'll see more of this. Delete front is over. Now delete end. Okay, so let's see delete end. I'll just clear this. Okay, so I assume that you have one more node. Okay, this is previous, and this is null, right? So if you can see what we have to do, basically, if I want to delete a node from the, last node from the W linked list is we have to make this particular R link as null. This is what we need, right? We have to make the R link as null. This is the major thing we have to do. Okay. So now what we are going to do is we are going to take 2 pointers. Assume that there are 10 or some nodes are there here also. So from starting from the first node, we are going to reach to the last node. Starting from the first node, we are going to reach to the last node, right? Because we want to delete the last node here, right? So using a while loop, we are going to traverse the nodes, right? And as you traverse the node, I always told you, if you want to delete a node from the last end, in the end, we have to keep 2 pointers to keep track. One is the current pointer and one is the previous pointer. This was already done in the single linked list program. Okay, because since you are going to delete the last node, the current node, I need somebody to hold the last position now. That is the previous node. That's the reason I'm going to keep 2 pointers here, CUR and PREV. PREV is nothing but one step behind CUR, that is last but one node, right? So there are 2 node pointers here. Okay, so I'm going to traverse the node using this while loop, starting from the first node to the last node. So in the end, this will be my CUR and this will be my PREV. As I had shown the similar thing in the similar thing was shown you for the single linked list also. Okay, so here this is what I reached to my last node here till, because my R link is not equal to null. Once it becomes null, I'm coming here. Now what I'm going to do here, I'm going to delete the last node. How I'm going to delete it? By doing this. Okay, these 2 statements. There are, just see here, students, there are only 2 statements. Rest all remains are the same, similar to your single linked list program. Okay, so what I'm going to do is I want to delete this particular node. I want to delete this particular node. So for deleting this particular node, a very simple function is available, that is free of CUR. That every one of you know. But before I delete this, I have to make this node as the last node, right? I have to make this node as the last node. So how I'm going to do that? Simple. As I told you in doubly linked list or in any single linked list also, the last node will be always pointing to null and there will be no backward node. There will be no backward node. So what I have to do is the R link of this particular previous will become null. That's all. Only one simple statement, previous of R link, make it as null. Okay, previous of R link, make it as null and then free this current node. That's all. So this node will be deleted and this becomes your last node. So if you can see here, there are only 2 sets of statements which you have to do. Okay, so this is what I have commented for every line and I have made you people understand what is this happening here. Is that clear, students? So that was your doubly linked list where your having only two minor changes I have told you. That is, you have two kinds of pointers here, forward as well as backward pointer. And the first node will be having a backward pointer which points to null. That is the only difference between your singly linked list and doubly linked list. Okay. Shall we proceed further? Any doubts in doubly linked list? Anybody has any doubts can put it in the chat window so that I can clear now itself. Anybody has doubts? Yeah. Anybody? Okay. Okay. Let's proceed further as you've already seen the demo now. So no need of showing you the demo again because you've already seen it. And let's move forward. You have one more program based on linked list, that is polynomial program, and that is based on your circular linked list, okay, with header nodes. Circular linked list with header nodes. Let's proceed further. Close this. So let's come to circular linked list. So this is the overall idea of circular linked list, where the last node will have a pointer which will again point to the first node. Okay, that's the reason it is called as circular linked list. The last node will have a pointer or a link which will again point to the first node. That's the reason it's called as circular linked list, and traversing will be very much easy for us if you are using such kind of linked list because the last node is connected to the first node. Okay, so there are some differences since it is connected to the first node. Let's see here. Okay. So you can see here, if I want to insert a node, from the front end, now what is the major difference I'll be doing here? Okay, so since the last node is connected to the first node, right? So here, whenever I'm inserting a node to the front end, sorry for that. Whenever I'm inserting a node to the front end, the two steps we have to do is the last node link should be connected to the node, right? And the forward link of that particular new node should be connected to the second node. This is the two steps we have to do. So for each linked list, the variations of linked list, you need to first understand what are the small variations you have to do in your line of code depending on the way it is. For single linked list, it's very simple because you just have to move forward in one direction. For doubly linked list, you have two changes. You have to also maintain the backward as well as the forward pointers. Now, in case of your circular linked list, again, you have a very small variations where you have to see that the link of the last node should be connected to the first node, right? So this is the variations. So I have a very simple idea is that whenever you get questions on any kind of linked list, what you can do is you can just draw a simple diagram. No need of a neat diagram, just for your reference, a simple diagram of whatever. If they ask you circular or if you ask you doubly, just name the nodes, give some name to the pointers, okay? And depending on the way, suppose you want to insert from the front end. Now you saw with the diagrams is how easy it is to convert it into a code, because easily you can write previous should be connected to right link, right link should be made as null. So you yourself can draw the diagrams and write the code and transfer it to your program. Okay, so simple idea, no need to memorize your programs, no need to understand the code. Also with the simple diagram you can yourself write the code. So in front of you also you have a code where you need to insert the node from the beginning of the linked list. So simple here, this is the last node, right? And suppose I want to create a new node here. So what I have to do is I have to and next is the pointer basically. So what they are doing here is connecting the last of next, okay, to the temp of next, right? And temp is connected to last of next. So this is what it is. So what exactly happens here is, this is how it happens here. Basically, this is the node, suppose. Okay. So what I have to do here is, last of next is what? Last of next is this particular node, right? Now at this point, at this particular point, at this point, my last of next is pointing to this node, what you can see in front of you now, right? Now, when I want to insert a new node here, okay, I have to connect this two node, right? And second point, I have to also connect this part with this part, right? So this is what we will be doing now with this particular statements. What you can see here, this particular statement, what you can see here, it is doing exactly the same. Okay, last of next is this and temp of next is this. So there will be a connection between these two now. Okay, yeah. Now what is the second thing I have to do is I have to remove this connection now, right? I have to connect this part, okay, this part with this part. Okay. So what I'm going to do here, this is my temp now. Okay, as far as the program, what you see, this is the temp. So temp, I am going to assign to last of next. Okay, so my last of next will start connecting to temp. So this will start connecting here. Okay, here. So this is how it is. So this becomes my insertion from the front end. So here there is a very major change. Unlike your singly and doubly, you have this particular thing. You have to take care of this last node because the last node is always pointing to the first node. So when I mention last of next is nothing but you are talking about the first node here. Okay, first node here. Don't forget that my last of next is nothing but the first node here. So with this statement which you can see in front of you, you are connecting this node with the temp of next. So this is my temp, that is the new node. Okay. After you have connected this, now I have to connect the last node with the first node, that is my temp. So this is what is happening in the second statement. So this becomes my circular linked list inserting from the front end. Okay. So this is how you have to write your code by understanding how it is been done using a simple diagram. You can do it very, very easily. Is that clear? Yeah. Similarly, you can see here inserting from the rear end. So what I'm going to do here, rear end. What is the connections? Now you can yourself write the code. This is my circular linked list, say. Then you have this linked list last, which is pointing to the last node, and this is how it is. Now, if I want to make this as my last node, what should I do is, first thing is I have to connect this part, the null part, to the first node. So I'll have some name here, say first. That is very much important here. Say this is my first node. Okay. So this is my first node. So I have to connect this temporary node, which I'm going to insert from the red part. I have to connect this here, right? So this part, the link part of this last node should be connected to the first node, right? And then what we have to do is the last node, which was the previous last node. Now this has not completely become the last node. So this link, the forward link, only one link, the forward link should be connecting to the temp part. So last of link, I will assign it to temp. last of link, I'll assign it to temp, and temp of link, I'll assign it to first, right? This is how we will write the code, right? Last of link, I will assign it to temp, and the temp of link, I'll assign it to first. So this completes my inserting from the rear end. Okay, so this is how students just draw a simple diagram, just give some name to it, understand how you can insert it, and then just try convert it into the code. This is what you can simplify your programming skills. Okay, so this is what we did. Continued, last of next, temp of next, and temp is last of next. Yeah, yeah, some applications of doubly linked list I just had mentioned about it. You can see, one second, there is this. Yeah. I had talked, already told about the music players of doubly linked list application, as you can define your songs, you can forward the songs, you can go to the first song, you can go to the last song. So most of the music players used doubly linked list as their data structures, right? Undo and redo operations. This is also an application of stacks. So very obviously it becomes application of your linked list also, because linked list itself is a big application of stacks actually. So undo and redo operation, which you already do in Word document as well as any other documents. Okay, so you can understand how whatever you have, the work you have done is stacked or put it in a linked list, and then when you do undo, it pops up, redo, pushes, push, pop, all the operations. Now you can understand it clearly how it works exactly, and how efficiently our linked list, our stacks are used by our operating system to carry out all these operations. So whatever operations you do, right, is stored in a stack, right? And whenever you say undo, it pops up, right? And redo, pushes, all such operations. Now you can imagine that. Now also the browser cache, which allows you to move front and back, right? So if you can see, you must have observed, right? Back button, what it does, it moves to the previous pages. Front button, it moves to the whichever pages you have browsed, right? So everything is kept inside and stack, or you can say it's stored in a linked list. And then you can, with the help of your previous link and with the help of your forward link, you can use the URLs which you have already browsed. So now you can easily relate about the applications as well as the exactly where you are going to use all these things. Now you have already been studying the operations, but exactly in real time, how are you going to use this? So these are some of the applications. Major applications of doubly linked list are also used in your operating systems, which you may not be able to relate right now because you have not studied that subject. But majorly, it's also used in your operating system scheduling algorithms. Okay, so these are some of the applications. So since your program has a variation, since the lab programs have circular linked list with header nodes. Now, exactly, somebody in the morning were asking about header nodes. So all your linked list will have a variation, or the first node is may or may not have an head. I have not also mentioned that it may or may not have a head, means not necessary that all linked list should have a header node. Now, what is a header node? Basically, it is not a node which will contain the actual linked list data. It will contain some information about the linked list. For example, you want to store how many nodes are there in that particular linked list, or you want to store some name of that particular linked list, some important valuable information. For example, header node acts as a title. Okay, basically it gives some information about that linked list, but it does not contain the actual data. You are not going to store any data in the header link. But if you are using a header node, it should be the first node of your linked list. This is what I can make you understand. Okay, first node should be your header node. Till now, whatever program we saw, doubly linked list, singly linked list, there were no header nodes involved. Okay, you can give your name, first node name as head. Okay, but not necessary. If you name it as head, it becomes an header node. Now, header node occupies memory location. So it is actually, it's not actually a data node, but it contains information about that particular linked list. So it's an extra node that is attached to the front end of your linked list. So it can be a single linked list, it can be a doubly linked list, or it can be a circular linked list. Okay, so basically, in simple words, header nodes are the nodes which contain information about the linked list, but it does not contain actual data. Okay, so this was about your header node. So all your linked list program can have this extra node called as header node. So this is how it is created, the header node. So if you can see here, there is no data stored here. The data is stored here one after another, but there is no data stored here. But if this is an example of circular linked list with header nodes. So if you can see here, the last node is connected to the header node, right? And then header node is connected to the first node, okay, which is the actual data. But if you want to traverse a linked list, it should always start from the header node. If you have a header node in your linked list, it should always start, traversing should start from the header node itself. Is that clear? Okay, so this was about your header node, because the last program which we are going to see now, that is the circular linked list program, it contains header nodes because they are mentioned specifically. It should be an header node. That's the reason I'm giving you an idea of what is an header node. So just to, we have already seen all this part, but just to make you people, so this is your circular linked list, right? We have already mentioned all these things. I've already done this, insert to head of the circular. So in this case, there is no header node. This head doesn't mean that it is the header node. It is the first node. They're talking about the first node here. So we have already seen inserting to the front end of the circular list, inserting to the rear end. It's just an diagrammatical representation for you people. Okay. So let me come back to the program here. You can see here deleting node, delete node. Suppose if I want to delete this particular node. So in case of your circular linked list, now what is the, in case of your circular linked list, I already mentioned that the address of the last node is pointing to the first node always. Now, if I want to delete this particular node, then I have to make the address of the last node to point to the second node, right? So what should I do here? I should have two pointers again here, which will first point here, the first pointer, then I have to go to the second node here, and I'll have to stay here, make the last node link point to the second node, and then delete this particular node. These are the steps involved here. So what is the steps involved here? First thing is you have to start from the first node and you get the address of the first node through the last node itself. In case of your circular linked list, you can get the address of your first node to the last node link, because the address of the first node is pointed by the last node link. So I get the address of my first node to the last node link. I go to the second node through this forward link and I stay here. Then I start pointing the link of the last node to the second node. So this becomes my first node now, and then I free this particular node. Okay, so this is the procedure to delete your node from the front end of your circular link list. Okay, so there are three steps here basically, right? Yeah, this is to delete a middle node, which is basically not there in your syllabus, but just for your understanding, deleting a middle node CR from circular linked list. So if you want to delete a certain node from a circular linked list or a single linked list or a doubly linked list, here there should be two pointers that have to be maintained, because you have to keep track of this node as well as this node. For say example, I want to delete this node, right? So if I want to delete this node, there should be connection between this node and this node now. So I also have to keep track of the previous node as well as the next node. Okay, so this is what is happening here. If you can see here, this is my previous of next point to CUR of next. Okay, what is my previous of next should be pointing to CUR of next. And then I have to delete the current node. So what will happen? A link will be created between these two, and then I'm going to delete this, right? Delete particular nodes. So this is when you want to delete a node from the middle of your linked list. Now, suppose if you want to delete a node from the end of a circular linked list. Now, as in case of your circular linked list, again, I will repeat it. The address of the last node, the address of the last node is pointing to the first node itself, right? The address of the last node is pointing to the first node, correct? So what should I do now? I have to delete this particular last node. So what I have to do is I have to keep track of a previous node, last but one node, because now I want to make this as a last node, and it's a big task, because now the address of this last node should start pointing to the first node. This is a big task, right? Okay, so what I'm going to do here is, yeah, CUR of next, assign it to previous of next, right? So this is my previous, assign it to previous of next, CUR of next, assign it to previous of next, and then delete this CUR, right? Previous of next, delete this CUR. So is it clear? So the three main jobs here is, first thing is, since the last node is always pointing to the first node and I want to delete this, what I have to do is here the last, I have to keep track of the previous node, because now I want to make this as my last node. So I will take the address of this, okay, and then I will start pointing to the first node here. First node here, that is CUR of next. CUR of next is nothing but the first node. CUR of next is nothing but the first node, which I will make this start pointing with this statement, previous of next. Okay, so this starts pointing, and then what I will do is I will delete this. Okay, so there are two particular major thing which you have to do here. So everything, whatever we did from the previous 4 slides, it's just written in a code format here. Okay. Right. So simple application again the same application, just like your doubly linked list. Circular linked lists are useful for playing video and sound files in looping mode. Right. Now you can understand, right, that why it is in a looping mode. We talked about the looping mode because if you can see, the circular linked list itself acts like a loop, because the last node is pointing to the first node, right? So you can say that circular linked lists are useful for playing video and sound files in looping mode. So you can repeat the songs again and again. Once you finish all the tests, or say for example, you have 10 songs. After finishing the 10 songs, the first song will be played again. So that becomes your example of circular linked list. Okay, fine. So I hope you have understood the concepts, every one of you. Any doubts in circular linked list? Anybody has any doubts? Anybody? Any questions? Any questions? Yeah. So you have a program, students, polynomial program, where you have to add two polynomials using circular linked list header files, header nodes. Okay. So you are going to add two polynomials basically in front of you. This is how it will be stored. So this is the first term of the polynomial, this is the second term, and this is the third term, whatever you are seeing in front of you. This is the first polynomial, this is the second polynomial, and how it is going to get stored in the linked list. Okay, so this is coefficient, this is exponent, coefficient, exponent, coefficient, exponent. This is how it is, and the result is right in front of you. So first of all, understand how it is being shown, or how it is going to be represented in a linked list, circular linked list. Okay, so this is how it is. You will be having a header node here, and this will be coefficients and power will be stored in this data linked list node. Okay, and the more terms and the more nodes here. Okay, so this is how it will be. So if you understand this representation, then program will be easy for you to understand. Is it clear? Shall we proceed with the program? Shall we proceed with the program? Polynomial program is a big program. Let me show you the demo first. Let me share the screen. So you can see here, there are two options given here. One is to evaluate the polynomial and one is to add the polynomial here, right? So let me start with first option. I'm going to give coefficients and I'm going to give the power of x, y, z, as well as for evaluation, I'm going to give the value of x, y, z. Okay, so numbers, give some simple numbers. So if you want to wish to continue, press 1, otherwise 0. I'll just stop it here. So this is my polynomial right in front of you. You can see 3 raised to x, y raised to 2 and z raised to 3. Okay. Now I need to enter values of x, y and z so that it gets evaluated. Okay. So this is my result. If you can manually do it, you can see the result is 324. Okay, so this is the evaluation of polynomial. Evaluation of polynomial. Okay, now let me come to choice number 2, where you're going to add two polynomials. Now, if you know that like terms get added and unlike terms get just added to the resultant, just get appended to the resultant polynomial. So let me first give the like terms and then let me give you two unlike terms. So we'll see both the options here. So coefficient is 2 and let me x, y, z 3. Okay, so let me give the same one. I don't want to continue with, I just want one term. I'll just put it one term. So second polynomial coefficient is 3 and x, y and z. Okay, so 0 and I can get the addition. It should come 3 plus 2, that is 5. Yeah, so you can see the output here, 5 raised to x raised to y raised to z. You can see here the like terms got added here. Correct? Yeah. So now let me go for unlike terms. Since all were like terms, 2 plus 3 got added here. 2 plus 3 got added here. Okay. Let me go to unlike terms. I'll just continue with that. 2. So I'll enter the coefficients 1, 2, and 3. Let me give something else. 4, and let that coefficients be 4, 5, and 6. 0. Yeah. If you can see here, since there were unlike terms, it just got appended. So right in front of you, right? It got only appended, right? That is right in front of you. So this is how it works out. Now you can add more terms. It's not necessary. I have only used one term just for an example. It works with 2 terms, 3 terms, 4 terms, how many terms you want. Okay. So I'll just pass on this program to you. You can execute and find out yourself. The aim of this is to understand how this program actually works. That's the reason I explained you circular linked list with header nodes. So you understand how exactly it works. Okay. So this was about your polynomial. I'll just exit from here and I'll show you the program. Okay. So let's see here. You have a polynomial program. This is a polynomial program and it is implemented using single circular linked list with single circular linked list with so this is a singular circular linked list with header nodes. So you are going to represent your polynomial just like I showed you in the slide that you are going to store the coefficient and the powers in a node, right? So here you can see the structure of the node. Okay. So let me tell you why is this flag used later on when I'll show you exactly where it is used. Okay. So now this becomes my structure of the node. This is the coefficient. CF stands for coefficients and Px, Py and Pz stands for the power of the polynomial. Okay. Now I have defined the node. I have defined the node. I have a function called as get node here where it works similar to your create node. Okay. Just like unlike your single linked list and double linked list program, you had a create node function. Similar to this, you have a get node where you're going to create an node to store your power and coefficients. Okay, so this is the get node functions. You can see here we have used here memory allocation. Okay, okay. This is a display where you're going to show your polynomial. Let me come to the main part here. Yeah. Let me start with the main program here where you have three nodes here, H1, H2 and H3. So each H1, H2 and H3, H1 is for the first polynomial, H2 is for the second polynomial and H3 is for the resultant polynomial. Okay. So this is for the resultant polynomial. And since we are going to use header nodes, that's the reason we have named it as H1, H2 and H3. Okay. So header nodes will be the first node in your polynomial, first node in the polynomial. Remember that. Okay. Now what you're going to do, this is the while loop. This is the main program where you're going to ask for the choice, whether you want to evaluate or whether you want to add the polynomial. So there are 2 things here, right? So let's go to the major part now because this is the main program. You know what is to be done. So let me tell you first for the addition of polynomial, then we go for evaluation, which is little easy compared to your addition, right? So now first thing you're going to do is read the polynomial. So as you saw in the demo, you enter the coefficient, you enter the power, right? So this is where you're going to read the polynomial. So read the polynomial, I'm going to read it. So let me come back to the program. Yeah. So this is where you're going to read the polynomial. Okay. So I'm going to enter the polynomial and I'm going to insert it from the rear end. One second, students. Am I audible? Am I audible, students? Yeah. Sorry for the disturbance. There was some network problem. Okay. Uh, Okay, so as I told you, I showed you in the slide that you're going to add the number of terms, and as you keep on adding the number of terms, it is going to insert from the rear end. I showed you the slides, right? Like, so here you're going to use the function insert rear, where you're going to add the coefficient and followed by the power. Okay, this is the header node. Okay, which will be always there in the function call, right? Because you're going to start your traverser or any operations starting from the header node. This is what I explained you. Whenever you have a header node in a linked list, your program should start with the header node itself, right? Okay, so I'm going to call this insert rear. So what it's going to do is going to enter the node one after another in case if you have more than two terms, or sorry, one term. Okay, so now this is what it is. So I'm going to create a node here and I'm going to enter the coefficients, the power x, y, z. I'll let you know what is this flag for. Initially it is 0. Later on I will tell you what is this flag used for. Okay, now I am going to link your header file with the CUR. Okay, CUR, and then this is how it is. So in case you have more than two terms, you are going to link one after another. This is the code to link one after another. Okay, so the first term will be CUR link temp. Next term, again this will keep on going on and on and on. Depends on how many times you are going to call this particular function. Okay, now if you want to wish to continue, you have seen the demo. If I want to add one more term, I need to press 1. Okay, and based on that one, again this particular function will be called insert rear. Okay, if I do not want a next term, I'll press 0. So this loop will not work. Okay, so depending on the number of terms you want to enter, that many times this insert rear function will be called. Okay, okay. Once you enter all the function, all the terms along with the coefficients and exponents, and your polynomial is ready, right? So you're going to call two times this particular, one for polynomial 1 and one for polynomial 2. Okay, so if you can see here, polynomial 2, read polynomial for 1 and read polynomial 2. Okay, once you have entered both the polynomials, you are going to call this particular function add polynomial, right? So, okay, let's see what is there. This is the major function where you are exactly doing the operation. So everywhere you can see I have commented here. Okay, it makes easy for you to understand what is exactly happening because there are many loops here, right? So let's see, I'll tell you the scenario, what happens, how it happens. You can visualize also how exactly it works. Okay, so in front of you, visualize that you have two terms, okay, two polynomials. This is P1, this is P2, right? What I'm going to do here is I'm going to start from the polynomial 1. Assume that there are two terms, okay? For your understanding, assume that there are two terms. There are two terms in polynomial 1 and assume that there is only one term in polynomial 2, okay? One term in polynomial 2. Just for your information, I'll just put, this is one node, this is second node, okay? There are two terms, assume that, okay? And this is one more, right? Okay. So now what we are going to do? I'm going to start from the first polynomial. See, I have commented here, traverse the first polynomial. And see here, students, you have one more while loop here, which is traversing the second polynomial. Remember and note that this while loop is an inner while loop. Okay, I hope everyone knows what is an inner while loop, the working of inner while loop. Okay, so when I tell something as inner, it should be within this, right? So this is the main while loop, the outer while loop. Inside this, you have inner while loop. That means what? You are going to take each term of polynomial 1 and you're going to check the term of polynomial 2. Okay, if you find that there is an like term, you are going to add it. You're going to add it, right? This is what is going to happen. Next, if you do not find any like term, you are going to just append it to the resultant polynomial. This is what you are going to do. So let's see here. Let's take the first polynomial. You have taken the first polynomial and then you are going through this x1, xy, py, pz and the coefficient. Okay, you are storing it in this variables. Next, what you are going to do is you are proceeding further to the second polynomial. Okay, you're coming here, second polynomial, and one second. What year you are? Now, can you hear me? Can you hear me, students? ಹೇಳಿದ್ರಾ? ಕೇಳ್ತಾ ಇದ್ದಾ? Okay. Sorry for this. I don't know what happened. Okay. Okay. So where was I? Let me start because I know the flow should not go. Okay. So this was my first polynomial. Listen carefully. If you understand this logic, your program is done. So this is my first polynomial. Assume that there are two terms. Okay. And this is my second polynomial, which has one common term with the first polynomial. Assume that there is one term xyz here also and xyz here also. Okay. Now what I'm going to do is I'm going to traverse my first polynomial one by one. I'm taking the first term. Okay. I'm taking the first term from the first polynomial and inside this while loop, I'm going to traverse the second polynomial completely. Okay. So I'm going to check whether my first term is getting matched with the second polynomial term in this particular if statement. Can you just check here, students? It's okay. So I've collected all the data, the exponent, the power from the first polynomial. I've collected all the data from the first term of the second polynomial, and I'm checking whether it is matching. Okay, whether something is common between both of them. If it is common, I have given this break statement. Okay, I'm given this break statement. Break means it will come out of this particular while loop. Okay, and what it does, if it comes out of this while loop, it is going to add this coefficients. Okay, it is going to add this coefficients. In case if I have a common term in between these two, I'm going to add this coefficient and I'm going to store it in CF. Okay, so okay, done. If I have a common term, I am going to add this. Now what I have to do with the term which has already been added in the second polynomial, I will make this particular term flag as 1. Okay, initially all the flags was 0. I will make it as 1. Now why should I make it as 1? Because it has already been added. So I have just made a comment here because I want you to understand the program. When you do it, you should understand it. Make the flag as 1 for the term which has already been added. Okay. So already the common terms have been added, right? So I need not see it for the next time. So I will make it as 1. Why is this needed? We will see again once. Okay. Now say if there are no common terms. For example, the first polynomial term does not match with the second polynomial term. So what I'm going to do, this break statement won't get executed, right? So I'm going to move further to the second polynomial, to the second term. Okay. Remember, I'm still in the first term of the first polynomial. Okay. First term of the first polynomial. I'm going to check the second term of the second polynomial, whether it is matching or not. If it matches, I am going to add it and make the flag as 1. If it, and then I'm going to insert rare. I'm going to insert this added summation along with the coefficients into the third polynomial, which is the resultant polynomial. Remember that, which is the resultant polynomial. Okay. Now, in case if it matches, this is what happens, which I've shown you. If it does not matches, then what we are going to do? If no common exponent is found in P2, I've commented it, you are going to insert that particular term as it is, right? As it is to the polynomial. This is what we have seen, and this is what we know from our maths knowledge, that if there is no common term, what we are going to do? We are not going to discard it. We are going to take that term and going to append it to the resultant polynomial. So this is what is done here, students. Just see here, if there is no common exponent formed, I'm going to take that particular coefficient of the first term in a polynomial and I'm going to insert it into the resultant polynomial. Okay, then what I'm going to do? Again, I'm going to proceed further to the second term of the first polynomial and continue with the same method. I'm going to check whether, there is common term somewhere here. Okay, already if the terms have been added, that means the flag will be 1. But there will be certain terms which will not be added, right? Which will, because it doesn't have common term. So that flag will be never 1. It will never become 1. It will be always 0, right? So that terms, the remaining terms, you can see here, insert the remaining terms of P2 to resultant polynomial. How to check whether what terms have been remained? You have to check the flag. Okay, that is the reason I told you. I will tell you later what is this flag. Okay, so the terms which were common got added and you got inserted into that third polynomial, that is the resultant polynomial, right? Now, if there were no common exponent formed, then you proceeded further from the second term of polynomial, you checked, and then you saw whether there is some matching in the second polynomial. If it is not there, so you are not going to initialize the flag to 1. The flag will be always 0. So what to do with the remaining terms of the polynomial? You are going to insert it as it is, right? So this while loop will become insert the remaining terms of P2 to resultant polynomial. Okay. Is that clear, students? Everyone understanding what is happening? The flow of the program? Anybody has doubts? Please let me know in the chat box. I'll show you the demo again and let you know how it works exactly. There are many scenarios here. The scenario is that polynomial 1 and polynomial 2 may have common terms and it gets easily added. So that becomes the scenario where the coefficients are, the powers are same and you can easily add it. Okay. Once you add the polynomial 1 and polynomial 2 term, what you have to do is, we cannot again, once it is added, it's of no use to us. So what we are going to do is, we are going to make the flag of the second polynomial, that particular term which is got added, we are going to make it as 1. Okay, we're going to make it as 1. And then we are going to insert the summation to the third polynomial, that is your H3, which is a header for your third polynomial. Okay, in case it doesn't match, there are no common exponent, then what you're going to do, you're going to take that particular polynomial and as it is, you're going to append it, right? Insert rare, this particular thing. Okay, now this was about your first polynomial. What if there are some terms remaining in your second polynomial also, right? There will be some terms which are not getting added in your second polynomial. Then you have to check whether in your second polynomial is the flag set to 0 or 1. If it has been set to 1, that means it has been added and we don't need it. But if it is not being set to 1, that means there are extra terms which didn't had any common exponents. So what we are going to do is, we are going to insert it as it is. Okay, so you can see here as it is. This is for all the terms from the polynomial 2. Is that clear? And then P2 dot link is nothing. What is it going? It is moving ahead and checking whether you have still more, polynomial terms which need to be added. And why, if you are seeing in this while loops, every one of you just pay attention. Everyone you have this. Now coming back to this, what is this? H1, H2, and H3. They are header nodes, right? And I always told you that in a circular linked list, the last node will be connected to your header node. So here you're checking whether your P2 is not equal to H2 means what? Have you reached to the end of your node? Because the last node will be connected to the first node, and the first node in this particular circular linked list is your header node. Okay, that's the reason it is checking this condition. Okay, whether it is an header node or not. Okay. So this was about your addition of your polynomial. Okay, and remember students, this is your inner while outer while loop. Okay, I've just mentioned everything here. Okay, this is your outer while loop. Fine, and this is your inner while loop, which is traversing your second polynomial. Okay, so you're taking each term from the first term polynomial and you're checking with each term of the second polynomial. Once you traverse the whole second polynomial, then you're going back to the next term of your first polynomial. Okay, so I hope you know the concepts of the inner loops, similar to your for loop, similar, the while loop also works the same way. So first it takes one input from the outer loop, and then it traverses the whole of your inner loop, right? Next, it will go to the second term of your first polynomial and check all the terms of your second polynomial. If in the second polynomial, if the flag has been made 1, that means the particular term has been added, the summation has been done. If it is not made to 1, that means it is an extra term which didn't find any common exponent. Then you have to insert it to the third resultant polynomial as it is. Okay. So this was about your addition of your polynomial. Now we'll come to evaluation. Evaluation is much simpler. You just have to find the values for x, y, and z. You have to enter the coefficient. You have to enter the power of x, y, z, and then you have to give the value of x, y, z here, right? And once you enter the values, then it should get added. Now you know, everyone knows how to do the evaluation, simple maths, where you're going to substitute the value of x, y, z. So here, this is what it is. So this is a summation. If you can see here, result is assigned to result because this is a continuous summation, right? So you are going to store each term in a node. Okay, and again you're going to check whether it is not equal to head. I just told you this is for your circular linked list with a header node, where you have to check whether the last node is linked to the head. So the while loop will keep on working and it will go to each node here, h1 of link, each node, and for each term it is going to find the coefficient and it's going to find the power, right? And then you're going to add it to the result. So this gives me the final result of evaluation. Okay, this is a very simple code. I hope everyone have understood it. Students, any doubt? Please let me know now, right now. Do you want to see the demo again? Anybody wants to see the demo again? Nobody wants to see the demo again? Any doubt in the code? Harshita has told no. Thank you, Harshita. So we understood, right? So I hope you have understood. I will share this particular program, and just go through. I have also commented so that you will understand what exactly is happening here. Okay, simple words I have made: check for common exponent, make the flag as 1 for the term which has already been added, no common exponent. Okay, insert the remaining terms of P2 to resultant polynomials. I hope when you see the demo and when you understand, it will be much easier for you to understand when you go line by line and understand the concepts. Just don't memorize things. I have already told you, understand it's very simple program, looks very lengthy, but very simple. If you have understood the concept, it becomes very easy. Okay, follow these comments, whatever I have given you. Okay, so things will be easy. And I always told you, visualize your linked list, or you draw the diagram of the linked list, give certain names and try to draw diagrams and try to convert that diagram into 2 or 3 lines of code. That's all I have shown you. Even though it looks very big, adding the node to the front end with the diagram, things will become very, very simple. Okay. So similar to this is a polynomial. Imagine that your each term of the polynomial is a single node. Okay. So just you have to imagine this way. Each term of a polynomial is a single node which is connected to each other. That's all you have to imagine. And the last node is connected to the header node. Okay. What is a header node? It is the first node of any single linked list or double or a circular linked list. Since they are specifically told they have want an header node, so you have to include this. Okay. So the last node will be always connected to the header node. That's the reason if you see all the while loops, if you can see here, P1 not equal to H1, because it is to ensure that you are not you have reached to the end of your linked list. Okay, that's the reason header, because header is the first node of any linked list in case if you are using it. Okay, so I hope there are no doubts, students. In case you have any doubts, you can personally ping me and ask me. I'll explain it once again. Okay, so with the example I've shown you, demo also have shown you. So try to execute these programs, get the output on your own, try to write it, write the programs, keep a practice of writing the programs so that you have a strong hold on your syntax part. Okay, and with that you will also know the flow of the program, how it works exactly. Is that clear? Okay, it takes time, but practice will surely make you perfect. Fine. So tomorrow we will see 3 topics. One is trees, one is graphs, and another is hashing. I'll try to complete the program morning itself with showing you some slides about the concepts, a little bit concept of all the 3 programs and the output of the program. Is that clear? Shall we meet tomorrow then? Okay, we'll end the session now and we will meet tomorrow with 3 more programs. Is that okay? I hope you have understood all the 3 programs and the 3 concepts which we learned today, the double linked list, the circular linked list, and the single linked list. Is that clear? Okay, we'll meet tomorrow then. Thank you very much, students.